So I prepared these all slides from the data flare, and you guys can in the data flare site there is a course also free. You can join there. So there's dataflare.com. You go, so you can data flare training, and here is a one Hadoop course, and so many other courses are free. So you can join these courses. You can join and get the material. Okay, Scala is there, Hadoop Spark is there. So you have to join with your account. So I have prepared from the Dataflare website blog. So this document I prepared. Okay. Okay. I think anybody is going to join us. Okay, let me start. Okay. Okay, so what is a prerequisite for the learning big data? Because nowadays the cloud and DevOps is included also in the big data syllabus, but that is not very extensively needed. But we need it basic cloud services, and later on we will learn Lambda, Glue, EMR, and DynamoDB, RDS. So these are the specific services related to big data. We will learn in the AWS. Okay, so this is a prerequisite thing. So Linux command and shell scripting. Hello. If anybody is asking. Okay. So when we are starting to learn big data, we need a Linux command. So basic fundamental Linux command we need, because when we are doing Hadoop commands also, I will show Hadoop command when we are running, we need a knowledge of, okay, we need a knowledge of Linux commands. Okay. And the shell scripting is also needed whenever we are writing the job scheduling, right? And we are writing a shell scripts. So we are calling a multiple jobs, right? So one job after another job, and what is the output is coming on the one job, whether it's a successful or failure, depending on that, we are calling another job. So we need a shell scripting knowledge. So in shell scripting, we should know how to use operator functions, okay, and shell scripting, like how to use Linux command in the shell scripting. And cloud basic knowledge is we needed, like EC2, how to create a EC2 instance, how to create AWS account, S3 bucket, how to upload file, versioning. These are the basic fundamental in the S3. Like S3 is the storage file system, right? It's a cloud-based storage file system. It's an object storage file system. So we can upload files, and these files we can use for our data analytics. Okay. And EC2 we are using, EC2 is we are using for creating an instance. So we will create a Ubuntu instance or any other instance we can create, and there we can do some installation. Okay, and we can use EC2 for the different purpose we can use. Okay, and DevOps side we need a Git. So basic Git fundamental knowledge, like how to check in, check out code, clone the project. Okay, and we should know how to resolve the conflict. So basic Git commands is needed. Okay, Python basic programming is needed. When we are learning the Spark, so we need a Python. Okay, so there we will be learning PySpark. So PySpark, we need a Python programming knowledge. There we should know the functions, loop, and operator, and other things like you can say object oriented programming, as well as the functional programming. So there are so many things are there. File handling is there, exception handling is there, but at least basic fundamental knowledge, right? How can we understand the Python code, or we can write the Python code? Okay, and basic Java, if somebody knows like basic OOPS concept and the classes, interfaces, those concepts. SQL we need. Okay, SQL we need basic SQL queries. Generally, we write day-to-day life SQL queries. We write plain SQL queries, right? Select star from table, and update queries, delete queries, group by having queries, and windowing functions. So there are so many things are there, but basic SQL queries knowledge is needed. Okay, so let's start first big data framework. Okay, so what is a big data? Okay, so when we are doing the analytics in the big data, we are doing the analytics of the large amount of data. Okay, so when we are doing the analytics of the large amount of data, that is called big data. Okay, so big data in the layman terms, if you understand, right, in the traditional like if I say the file system or SQL databases, they cannot handle the large amount of data. So when I'm talking about the data, which is more than the GBs, TBs, or petabyte data, and that can be handled on the Hadoop file system, like some framework which can handle it. So the Hadoop is one of the implementation of the big data framework. Okay, so Hadoop is providing computation as well as it's providing the storage. But nowadays we are using Spark, that is an extension of Hadoop, extension of Hadoop MapReduce. Okay, so Hadoop is still there. Hadoop means two things are there: HDFS and MapReduce. Okay, so HDFS is a storage component, and MapReduce is the processing component, which is processing the data. So still, if I say if I'm using Spark, so Spark has replaced MapReduce. Spark has replaced MapReduce, but still Hadoop is there. HDFS is there. HDFS is there, and this HDFS is a storage. It's a storage which is used to store large amount of data processed by Spark, MapReduce. Anyone can process it. Okay, so the first we need the data in HDFS. Without having the data in HDFS, we cannot analytics. We cannot do any analytics on top of the data. So whether we are using Spark, so we need a data on HDFS. But Spark has a more flexibility. It can, without without Hadoop file system, it can process data. Suppose my data is not in HDFS, but data is in the local file system, so I can use Spark in the standalone mode. So standalone mode, standalone is a one, another one is a yarn, that is a Hadoop, and another one is a Mesos. Okay, these are the three different cluster managers are there. So if I want the data, I want to process in Hadoop, then I have to use yarn cluster manager. So that will come in the Spark. Okay, so I was simply talking about the when I'm hello. Okay, so what is big data definition? So I have some characteristics of the big data. Okay, so I can say the data is the big data. What are those characteristics are there? I say high velocity, volume, and variety and veracity. Okay, so if I say velocity, so when the data is coming very fast speed, so that is basically the data is big data. So there are so many examples are there where the data is the speed of the data is very fast, right? If I say the sensor data in the flight, okay, so this sensor data is the velocity is very fast, right? 12 terabyte data is generated in the half an hour flight. 12 TB data is generated in 30-minute flight. It just have some assumptions, right? So 12 terabyte data is really huge volume, and it is coming in a very less time. So the velocity will be high, right? Volume divided by time. So we will get the more velocity. So here is velocity and volume both are the proportional to each other, right? So these are the characteristics. Like when I say the velocity is high, volume will be high, and variety is basically talking about when the data is different types of data is there. Like I say text data is there, audio is there, sensor data is there. That is a raw data. Sensor data is a raw data, and audio, video, photos, images, right? So data could be in any form. Okay, so we can divide three forms of data. Okay, structured data, semi-structured data, and unstructured data. Okay, so when I say structured data, the data which I can handle with the like as a traditional tool, I can handle it. I can say, okay, this is all text data. I can read it. It's a human readable way, like I can read it. And this data, I can easily say this is a string data, this is the number data, or some date value is there, that is a date type data. So structured data has fixed dimensions. Fixed dimension means it can be easily measured. Okay, and unstructured data, it is not fixed dimension. Okay, not fixed dimension. So like I can say it is using pixels. Okay, I say images, audio, video, photos. So these are processed by some specific APIs. So I can use Java, Python, image processing API, video processing API, image processing API, video processing API. There are different APIs are there. We need to use those APIs to measure the data, right? I want to find how many duplicate images are there. So exactly I cannot see and find, right? Because there will be some minor differences are there. I cannot find directly. So I have to use some tool that can process and tell me how many duplicate images are there. Okay. So we need to use those kind of APIs. Okay. So unstructured data, which is not having fixed dimension, and we have to take it some additional APIs we need to use to process and the analytics on top of the data. And the third form is semi-structured data, which is the combination of structured, semi-structured. Like generally we put the category of like files data, right? CSV, JSON, XML. Okay, so file itself is a unstructured, but data in the file is a structure. Okay, so that is the reason we are calling here it's a semi-structure, and we are saying email. So email we have attachment is a image, right? Audio, or we can attachment we can do any unstructured data, but itself is a mail, body is a text, right? So that is structured. So these are the different categories of the like form of the data, but Hadoop can handle all. Okay, Hadoop can handle like Hadoop can store all types of data, because in file system we can store any type of data, right? So structured, semi-structured, and unstructured data. Any question anyone has? Okay. So now why we need a distributed environment, right? Because we know, right, data size is growing. Okay, data size is growing every day, right? And we cannot handle data in a one machine, right? We need a cluster. We need data size is growing, and we need cluster. Okay, cluster is the number of nodes in a cluster. Okay, and one machine has the capability, right? I say if one particular machine has some capacity. Okay, so if I say one machine has like max 128 GB RAM, okay, and I say okay 2 TB disk, okay, SSD, and I say processor, okay, I say some okay 16 core CPUs. Okay, so these are the some limitation is there. Beyond that I cannot go. So suppose my data analytics, right, so more than this size of the data, how can I do this? So I need a horizontal scalability where I have a set of nodes in a cluster, and I can share the data across the node, and I need such a framework or such a tool that can handle the data in the multiple nodes in the cluster. So Hadoop is doing that. How is doing that? So there is further core components are there in Hadoop, like SDFS having the name node and data node. I will come on top of that. Okay, so first thing is the vertical scalability. Vertical scalability is where we have limitation. We cannot extend the RAM, disk, and we have the resources. Resources we cannot increase more after certain limit, right? I cannot increase. So vertical scalability generally is in the SQL databases. Okay, so SQL databases have the limitation, but now some SQL databases, they are expanding. They are giving the feature of partition tolerance, right? The data can be shared across the machines. Okay, but still some databases are still having the limitation, and they are vertical scalable. Okay, so they can increase in the same machine, but not across the cluster. Okay, in the multiple machines. So SQL databases, and when I say horizontal scalability, so Hadoop is supporting horizontal scalability. Horizontal scalability is like I have 10 nodes in my cluster, and I want to increase any number of nodes, right? I can add more number of nodes in cluster. Okay, so when I'm adding it, so definitely my size, disk, memory, everything will be increased, right? It will become multiply. And who will be managing this? Like Hadoop is an open source tool, and that will manage this complete infrastructure, right? So how we are just writing a file. Suppose I have a 100 GB file is there, okay? Or some set of files are there. I want to store in Hadoop file system. So when I write this file, write the file in HDFS in Hadoop file system, it will automatically distribute the file depending on the size of the file, and it will broken into file into multiple blocks. Okay, blocks is like 128 MB is a default block in Hadoop. That is a default block size, 28 MB block size. So it will broken the file, and then it will distribute the file into the multiple nodes. And these details about the metadata about this distribution of the blocks into the number of nodes will be stored as a metadata in the name node. Okay, so name node is a master node in Hadoop file system, and that is containing all this metadata information. Okay, so that metadata information will be used by the Hadoop, like anytime, like you are going to read the same file or you are going to write different files. So it will store, and all those IPs of the all data nodes machine, it will store as a metadata. So this name node is a single point of failure. So if this name node is down, so we cannot access our data. Okay, so for that, Hadoop has provided the high availability. So high availability, there is a backup node is there, or there is a standby name node is there. So there are many different concepts are there. So high availability is very important in Hadoop, right? Because we are using commodity hardware for the data nodes, like where we are storing data, where we are storing actual data, we are using commodity hardware. So commodity hardware means like the hardware which is not very costly, like very low configuration RAM and low configuration disk space, because our name node configuration should be very high, because name node should not be crashed, right? Or if any point of time it is going to crash also, so we should have the backup of that name node. Okay, so there is a replication, and those concept will come. We will understand about what is the replication, how we can do replication of the data on the different node, providing the high availability. Okay. Okay, so when we come to the Hadoop journey, right? So initially the Hadoop project in 2002, right? Dog cutting is a guy who started. Initially, the paper is published by the Google File System and Google Mapreduce. So two papers came in beginning, and Google has not put more attention on that. So one guy, dog cutting, he started in 2004, and he started with as a crawler, right? He started journey of Hadoop. So how he choose this Hadoop as a logo, right? Because he saw his son playing with the small toy elephant. Okay, so he just kept as a symbol of Hadoop as a small toy elephant. Okay, so he started on these two papers, and developed two files, one file system, Hadoop file system, and Hadoop Mapreduce. Okay, so he has given the concept of Hadoop with the storage as well as computing. Okay, so Hadoop not only one single tool; it's a set of tools are there. Okay, so Spark, when we look at the Spark is not part of Hadoop ecosystem. It is extension of Hadoop, right? So Hadoop is providing set of its own tool, and there is a dependency of Hadoop file system, because Spark has no dependency of Hadoop file system. Even you can use Spark with Hadoop, or you can use Spark with HDFS, or you can use Spark without HDFS. Okay, so when we see Hadoop distributed file system, that is a storage component. Okay, on top of that, the Mapreduce and Yarn, right? Yarn is used for the cluster resource management. This component introduced in the Hadoop 2.x onward. So Hadoop 1.x, the initial release of the Hadoop, there was only Hadoop HDFS and Mapreduce. HDFS is storage, where we are storing our files, data, and Mapreduce, we are processing the data which is stored in HDFS. Okay, but in Hadoop 2.x and 3.x, because Hadoop MapReduce is not able to manage the resources, right? So for that, yet another resource negotiator, right? So this yarn concept came in picture in 2.x. So this is not only allocating the job to the resource manager and node manager. Yarn is basically managing the queue, right? How the jobs are, multiple jobs are coming, how the jobs will be scheduled, and how the jobs will be given the resources. So all those things will be managed by the yarn. Okay. So when we look at here, so here, like our data is stored. First, we understand what is a Hadoop distributed file system architecture, Hadoop architecture. So when I say Hadoop architecture, so two things comes in Hadoop architecture. So one is storage, that is HDFS, and processing, that is Mapreduce. Okay. And further we go like HDFS architecture. When I say HDFS architecture, I will explain about name node, data node, and secondary name node. Okay. And when I'm going to Mapreduce architecture, so I will explain the map. There is a job tracker, okay, and task tracker. So this is job tracker and task tracker in Hadoop 1.x. Okay, because this is the terminology of Hadoop 1.x. But same job tracker is changed to resource manager and node manager in Hadoop 2.x and 3.x. So 2.x and 3.x version is using job tracker as a resource manager that is allocating the task to the node manager. Okay, the same job, but here resource manager not only the allocating the task and handling the task and getting the status of the node manager, it is managing the resources also, managing resources such as hardware, CPUs, memory resources, CPU and memory resources, and queues, like job queues. So how many jobs are running, to manage those job queues, and scheduling of the job, scheduling of the jobs. So these are the things are managed by the resource manager. Okay. So when I say the architecture, so first I should know what is a Hadoop architecture and what is a HDFS architecture and what is a MapReduce architecture. Okay, so when I say HDFS architecture, so I should explain what is name node, what data node, how the replication happen between the name node, data node, and what is the secondary name node, that is basically the backup. But this is still 1.x, and the 2.x for high availability concept, they given standby name node, standby name node. The standby name node is the same as a name node backup, but it's a passive. Once the active name node will down, within a minute time, this standby name node will become active. Okay, so this is Hadoop 2.x and 3.x. Okay. So here, this is Hadoop 1.x architecture. Here is no standby name node and general name node concept is not there. So here name node is basically replicating the blocks. So everything in Hadoop is Hadoop distributed file system is block. Okay. So we say the data size, right? We are saying like, okay, we have the data in the MBs, GBs, TBs, right? Okay. But basically this data is stored in the form of block. And one block in Hadoop 2.x is in Hadoop 2.x is 128 MB. Okay. This block size, default block size in the Hadoop 1.x, it was 64. So why they increase this block size from 64 to 128 MB? Okay. Or it is still configurable. You can increase more than 128 also. Like some configuration property you change, and this block size you can change it to more also. So the reason is like we are processing the large amount of data. Okay. When we talk about in Windows and Unix, right, file system, they have also block size. So everything is stored in the form of block only, whether it's a Linux or Windows or Hadoop file system. But here is a one block is only 6 KB. Okay. And if you compare why, because this is their design, right? because Windows, Linux, we are using this file systems for a long time. Okay, because we are not meant for these file systems are for the large amount of data to process. We can store data, TBs file, GBs file, we can store, but we cannot process it, because even the like some 10 MBs, 20 MBs file, notepad file, I cannot open in the text notepad, right? So because they are not having such a block size. Okay, so but Hadoop file system design is done in such a way, right? If you are going to process, because not only you are storing the data, you are going to process the data as well. So when you are going to process data in large amount of files, right? So if less number of blocks will be there, it will be having a more like a speed, right? It will be reading the data faster, right? So that is the reason when we are processing the data in Hadoop, right? Either you are using Mapreduce, Spark, right? So that is different frameworks are there. Okay, Mapreduce is not that much faster because it's a batch processing, but Spark is faster, right? It's a in-memory computation. So that difference will come. But overall, if we say Hadoop is meant for like it's a large amount of files. Okay. So the keeping it larger block size, the purpose is to make it a less number of blocks so we can get more data can be read in the file system faster. Okay. So here is a name node is containing the metadata, all the data node data. So suppose one block, this is a block. Okay, so one block, suppose I'm a client, I'm requesting to the name node to write a file in Hadoop file system. So what name node will do, it will broken down my file into number of blocks, and it will store the blocks in the different data nodes. So here is the application comes when this particular one block is stored here, and it will make a one copy of the same block in the another data node. Okay, if suppose this data node is not down, if data node is down, so it will read the data from the another data node. So there is a heartbeat mechanism is there in between the name node and data nodes. So name node is the master, which is coordinating all the data nodes, which is giving heartbeat signal to the all data nodes. So which data node is not returning back the acknowledgement of the signal, so that means it is understood this data node is down. So how this is all things done by the name node. So we are not bothered about it, where our data is stored, in which data node is data is stored. We are not bothered about it. We are simply just requesting the name node, like we want to store this file or we want to read this file. Okay. So this all things are managed by the name node. So name node is using the secondary name node, because I told name node is a single point of failure. If name node is down, you can't access your cluster, even your data is there. Okay. So Hadoop has provided secondary name node concept. So in Hadoop 1.x, there was no standby name node. So this secondary name node takes half an hour time to start up. So it is getting the half an hour time delay in syncing the data. So name node and secondary name node is sharing the metadata. How secondary name node will know if any request is coming for some particular file, if the data is not there, the metadata, so secondary name node cannot access that file, right? So name node and secondary name node is syncing the data. So there is a fs image and edit log file is there. So we are this name node and a secondary name node is syncing the data between each other. Okay, so name node is basically providing the information right up to date in the secondary name node, but it is 30-minute delay. Like whenever like your name node is down, the secondary name node takes 30-minute time to start. So that thing is overcome by the standby name node, which is started in within a minute time. Okay, so data node is containing the actual data. The data which is we are storing in the files, the data is stored in the data node. Okay, so name node is a master node and data node is a slave node, which is so data node is containing the actual data. Okay, so name node is maintaining the two files. So one fs image file and one is a edit log file. So suppose name node down, but again it will going to up, right? So how it will, so fs image is a memory copy and edit log is a disk copy. So suppose your fs image copy is gone, so edit log will be like it is a backup, right? It is a store in the disk, right? So name node again will take up edit log file to create a new fs image. Okay, so that is a way for how name node maintain like a two file. One is an image memory copy and one is a disk copy. Okay. Any question? Okay, so these are the simply theory concept. Nothing is a practical in this, and this concept is just important to like you are going to tell like Hadoop. So basic fundamental architecture you should know. So when you are just going to explain what is name node, data node, what is a secondary name node, what is a job tracker, what is a task tracker. So these are the some fundamental concept. We are not going in deep like internally we are not going to understand like how these are behaving, how these are working, but at least we should know like what is the role of each of these components. Okay. Okay, Mapreduce is the processing component. Okay, so Mapreduce having the two phase. So everything is in Hadoop is Mapreduce. So here in Mapreduce, we are writing our own code. We are writing the code in the Java. Okay, and we are writing our own custom code of map and reduce. Okay, Mapreduce code. But if I say if I don't want to write a Mapreduce, so there are the other options are there. Like I can use Hive, I can use Scoop, I can use HBase, I can use other component I can use, but all the components are generating the Mapreduce, but they are generating on behalf of us, right? So we are not writing the Mapreduce there, but they are just converting into the our code into the Mapreduce. Okay, so that is the reason Mapreduce is gone only for just writing our code. Okay, we are not writing the code nowadays in Mapreduce, but understanding the concept of Mapreduce is still important, because if we understand the Mapreduce functionality, then we can understand how internally other components are generating the Mapreduce. Okay, so Mapreduce has the two phases. The core phases are two, but one shuffle phase comes in between the map and reduce. Okay, so map means simply splitting the data. I'm saying like, okay, I have one text file. Okay, and this text file has millions of words are there, and I want to do the word count. Okay, so if I say like if this data, if I distribute into the 10 machines, okay, and each and every machine is doing its mapper phase, what mapper phase will do? It will be generating the key value pair, and each word it will be giving one count. Okay, and basically we are doing the parallel processing here. So here, if 10 machines are doing parallelly, so my work will be faster, right? If I say if I'm processing the data only on one node, suppose I have a one node cluster or two node cluster, and I have a 1 terabyte file. So which will be more faster, right? Two node cluster or 10 node cluster? 10 node cluster will be faster, right? Because your data is processed on the 10 node parallelly. Okay, because mapper phase, like it's running parallelly, and each word is given a one count. And once your mapper data is given to the reduce is aggregating the result of all mapper machine into a single output. Okay, suppose I say hello is the one word is data. This data word is going 10 machines 100 times, right? So my final output should come 1000, right? Because I want to combine the result of all the mapper machines to in a one single output file. So that is being done by the reduce. Okay, so map and reduce. Map is basically splitting the data into number of machines and process parallelly. Reduce is basically it's again key value pair, but it is aggregating the result from the multiple machine to get a single place all the output. So that is the concept of map and reduce. Okay, if you see here, mapper machine have map task and reducer is having the reduce task. But we can create our multiple reducer also. I will tell about there is a partitioner concept is there. So it is not like only one reducer will be there. But suppose I want to generate my output into 10 output file. Okay. So I will tell you the use case where you need multiple reducer also. Okay. Suppose this word count output. Okay. Suppose this word count output, you want to say like I have A to G words are there. I'm getting in single file all A to G word. Can you find it a particular word which is starting with the C letter, or some word I said D letter? How much time you will take? If I say, if I create all separate 26 file for all these word count, so which will be faster? If I'm creating a 26 output file, it will be faster, right? So that is the use of the custom partitioner. So we can write in the Mapreduce our own custom partitioner class that will distribute the data into multiple output file, so that like we can easily read the data. Okay, so that is the use of the reducer, multiple reducer. Okay, so yarn is basically yet another resource negotiator. In the Hadoop 2.x, they introduced yarn because in Hadoop 1.x, there was an issue of managing the resources. So they introduced in the 2.x managing the resources by using the yarn, yet another resource negotiator. So node manager is acting as a like a node data node, okay, task tracker in the Hadoop 1.x, and resource manager is like a job tracker, okay, which is a master. So when name node gets a request of file, right? Suppose you are asking the read or write a file in Hadoop file system, so you are requesting to the name node. So name node is sending that request to the resource manager. So generally the client is sending the request to the you cannot directly send to the resource manager because resource manager cannot understand you. Okay, so resource manager will be taking a request from name node. Okay, so once request is taken by from the name node, so resource manager will be finding the node managers and it will be allocating the resources as a container. So whatever we are talking about, hardware, CPUs, memory, these are called containers. So every node manager has containers. Okay, so if you see here, then this is a node one data node, this is a second data node, this is a third data node. So every data node has one node manager. Okay, so who is doing actual task? Okay, so application master in each and every node has the application master. Suppose my data processing is done on these two nodes, because it is not necessary all the data nodes are involved in the data processing, right? Node manager is processing the data. So wherever my data is processed, right? So there the container, the resources is available to the node manager by the application master. Okay, so resource manager and one more application manager comes in picture here. Actually, it is not shown here in the diagram. So resource manager is having one application manager, and application manager is managing the sending the request of the task to the node manager, and application master on each node manager is managing the resources to the node manager to perform the task. Okay, so this is in the yarn architecture where the resource manager interacting with the node manager and application master, and then fulfill our job, right? So whatever the job we are looking for to perform our result, right? So we get the result, okay, after completion of the job. Next component is Hive. So Hive is very important because it's completely a SQL data warehouse tool. And now the cloud is providing also data warehouses tool are there, right? In Azure, there's a SQL data warehouse tool is there. In AWS, Redshift is there. Okay, so and the GCP is having the BigQuery is there. So similar tool is there, Hive. So but Hive is a part of Hadoop ecosystem. Okay, so Hive is having different component. Okay, so Metastore is there. So Metastore is containing the metadata about the tables. Okay, so when we are storing our data in the tables, and these tables are storing data as a file in Hadoop file system. So everything is stored on top of the Hadoop file system in the form of file. But we are able to see the data in tables similar to the same like a SQL DBs. So SQL DBs, you know, right? We are able to see the tables, but these data is not in a real-time tables. These are in the files, DBF file, database files. So these database files, our tool is reading the data and showing as an interface to us, right? So similar thing is here, okay? So Metastore DB is storing the metadata information about those tables. So whenever your request come to query a table, right? SQL query on table. So this Metastore DB will be giving the information about the table to the database engine. Okay. So there is a one Hive server is there, query compiler is there. Okay. So Hive server is basically the internal database execution engine is there, which is executing your queries. Okay. So first, whenever SQL queries is submitted on the Hive shell, then it is getting the data metadata information from the metadata store. So there are the different types of metadata stores are there. Local is there, remote is there, embedded is there. So by default is a Derby. Derby is a metastore DB is provided by the Hive. But suppose you want to configure your own on SQL DB as a metastore DB, you can configure. You can change in the Hive site.xml and you can change it. Like you can use Oracle, MySQL, SQL Server. Okay. Okay, so this is Hive. Pig is now completely outdated in the market. So Pig is okay. Yahoo, this Hive is initially given by the Facebook. Okay, now it's a part of Hadoop ecosystem, and Pig is originally developed by Yahoo. Okay, now Pig is completely outdated in market like last 2017. Now they have not given any release. So Pig is also one analytics tool. So we are talking about this Hive and Pig. These two are the analytics tool, and Mapreduce also analytics tool in Hadoop. Okay. So Pig is using the Pig Latin script, and this is like a ETL. Like generally in the ETL, somebody has the knowledge of Informatica data stage, right? So they are using the ETL operators, like ETL operators like load, dump, okay, filter, right? Different join. So these are the operators. So ETL operators are easy to perform our data processing, right? So Pig is providing the Pig Latin, that is a scripting language, similar to, right, we say Python is a scripting language, okay, and we can say Hive is also SQL scripting, and shell scripting is a scripting. So this way, Pig is a scripting language. So Pig is providing like Pig Latin script, and that is having different types of operators. So there are the operators, different categories of operators are there. So it is using the Pig Latin script. So it is converting into the Pig script to the Mapreduce. So when you are using the Hive queries, so this Hive queries is converted into the Mapreduce job. Okay, and Pig is converting Pig script to the Pig Latin script to the Mapreduce. Okay, so that is also converted into the Mapreduce. Okay. HBase is a NoSQL database. So I will be going through fast way like this. All these are the tools we have to deal with like in more details. So Apache HBase is NoSQL database. There are many more NoSQL databases are there in the market, right? Cassandra, Mongo, CouchDB, Neo4j, and these are the similar category is there HBase. But HBase is a column family database. So column family means the group of columns together make a single column family, and we can read and write the data from the column family. So it's a columnar file format database. So columnar databases are faster to read. Okay, so data can be read faster. So there is in HBase architecture, HBase master is there, region servers are there. So master is allocating the regions, right? Regions server is having the regions. Okay, so whenever the requests come to the master, and master is having the region server, and region servers having the regions, and there is the data is stored in the H file. So H file is like on top of the Hadoop file system, there is a one file is created, H file, and there is the data is stored. But when you are looking at the like a HBase, right? So HBase is having its query language. So HBase query language is there, like we can use like scan command, get command. Okay, so we can put command to write the data into table, create table command. So this is completely HBase is, but HBase is providing the faster access because it's using indexing similar to the SQL databases. So Hive is used for the historical data analytics purpose, okay, OLAP. But HBase is OLTP, right? Like online transaction processing database, like same like Oracle, MySQL, SQL Server. But here HBase is more than the SQL because it is not only SQL. So HBase is providing high availability, partition tolerance, and consistency. So HBase is following CAP. So there is a CAP, so consistency, availability, partition tolerance. We say in the SQL databases, we have ACID, atomicity, consistency, isolation, durability. So similar to like NoSQL databases, all NoSQL databases will be having the cap. So at least two properties of the cap will be followed by any NoSQL database. So here, like we have the concept of master region server. Mahout is machine learning, but nowadays nobody using Mahout. Mahout is a completely Java-based machine learning tool. Okay, similar to Mapreduce is outdated, right? Because of the Java, right? Because many people don't want to write a huge line of code, like 200 lines of code for the word count program, right? So similar way, like Mahout is a completely Java-based machine learning, like a framework. So it's outdated now. Nobody is using nowadays. So there are the many more. Spark MLlib is being used, right? So Spark machine learning libraries are there. That is writing a very small piece of code for like a writing a machine learning code rather than writing the code in the Java. Okay. Zookeeper is a coordination service, is a high availability service. Like sometimes I want to provide my name node high availability, or I'm using some other tool like Kafka, I'm using HBase, I'm using. So these are the tools are using Zookeeper as a coordination service. So how master server and region server will coordinate to each other, like if region server is down, so how master server will find the another region server. So Zookeeper is providing high availability. So we need to configure Zookeeper while we are installing HBase. So we have to configure Zookeeper there. So Zookeeper is a coordination service. It can be used anywhere. It is like a housekeeping things, like you want to like a coordinations like between the two component in a one tool. So that Zookeeper will be providing. Okay. So Zookeeper can be used in the Kafka, Zookeeper can be used in the HBase, and Zookeeper can be used in the Hadoop name node, right? So there also it can provide the high availability. Okay. Uji is a scheduler tool. So we need a one tool which can provide the scheduling of the job, right? So we have the ingestion tools are there in Hadoop ecosystem, analytics tools are there, and scheduling tool is there. So scheduling tool is a Uji. Uji is providing the like basically you can schedule a job on a particular time or ad hoc job, or you can have a frequently, like you are running a job, so you can use coordinator job. If you are having some workflow, suppose you have a Hive action, or you have a Scoop action, or you have a Mapreduce action, or you have a Java action, any type of action you can define in the workflow.xml. So nowadays people are using Airflow because some of the tools which is becoming outdated as per the market, because the new tools are coming and they are not having the dependency of Hadoop. Okay, so whenever the dependency of Hadoop is there, so you cannot do the data processing, right, analytics without Hadoop, right? So Airflow is a common tool, right? It's a tool which can be used for any type of application. It's a Java application. It's a like you can use for, it's a Python based tool. You need to learn Python when you are writing the DAC file in Airflow, but you can use this tool for any type of job. It is not having any dependency of Hadoop or not Spark, anything you can run, or shell script, Hive, Scoop, anything you can run with the Airflow. Okay, but you need to integrate. See, all tools it's not necessary to know which tools are completely outdated. You can remove it. You don't need to learn those. But at least some fundamental basic, like at least 2-3 lines of like a statements to know what is that tool, right? So if somebody is asking like which tool of like scheduling tools you have worked on. So if you are not saying like I worked on Uji, but at least you should know about Uji. Maybe this company will be using that particular tool is still, right? Some of the company are still using the Uji. I've seen in the Disney, and some companies still using the Uji. Okay, so if they are using, and some company is using the pig, right? You cannot, suppose somebody is working in the Yahoo, so Yahoo will definitely use the pig, right? Because they have their own tool, right? So still they are using pig. Okay, still they are using the pig, right? So you may have to learn depending on the requirement of the project. Okay, but I'm saying if you are starting from the beginning, it is not necessary you should go each and everything and spend more time in all those things, right? If the market and the project demands it, then you can go for that. Okay. Okay, so workflows are there. So basically Uji is handling the workflows. and UG is maintaining the DAG. So DAG is nothing but a direct acyclic graph, right? Maintaining all the actions in the one workflow.xml file. Okay. And this workflow.xml file having all actions, and one action is completed, then another action will be triggered, and like that it will be trigger all the jobs in the one workflow, right? So that will be done by the OG. Okay. Scoop is a very important tool, and it is used for the ingestion of the data. See, we cannot generate the whole data in the Hadoop file system because manually data cannot be prepared. Okay, so we need to bring the data from some other different databases, file system, right? We are bringing the data. So Scoop is basically bringing the data from the RDMS databases. Okay, Teradata, Oracle, MySQL, SQL Server. So all those SQL databases, like you can bring the structured data to the Hadoop file system. Okay, so Scoop is providing the Scoop import command, and Scoop is also having export also. Suppose you have created some file in Hadoop file system. Okay, you have generated some data in Hadoop file system, and now you want to export as a table in SQL database. So you can use the export. So import is basically bringing the data in Hadoop file system by using the Scoop import command. So you have to connect the database SQL DB. You have to provide the connect driver, URL, username, password, and then you have to provide the table from where you are bringing the data, and then final target dir you have to get directory location in Hadoop. So where you want to write the data in a file. So when your data is coming from the SQL DBs from the table, it will be coming comma separated delimited file in Hadoop file system. Okay, so we need to learn the Scoop import commands, and we need to use the Scoop. Flume is also ingestion tool. It is for the semi-structured and unstructured data. So semi-structured data, like a files data, you want to move to the Hadoop file system, or you are getting the data from the Twitter or some other streaming sources. When you are reading the data, you can use Flume. So still Flume is used in the market. Okay, some of the companies are using Flume for semi-structured or unstructured data. Like I want to read the data from the Twitter. So Flume has the three component: source, channel, and sink. Source is from where the data is coming. Sink is the final destination. The data will be arriving. That is Hadoop file system, Hadoop distributed file system. And channel is a medium, which is like file channel, JDBC channel, and memory channel. So you are transferring the data through either file, memory channel, or JDBC channel is basically specifically used for, like, you can get the data from the SQL databases also. So Flume is main purpose is unstructured and semi-structured, but Flume has given a way like you can read the data from the SQL databases also. So they have provided the JDBC channel. Okay, so we can use the source channel sync, right? We can define. Ambari is like a server, right? Like managing the Hadoop cluster, right? So Hortonworks has the Ambari proprietary tool. And if you see the Cloudera is having the Cloudera manager. So that is the server. So generally, whatever this name node, data node we are talking about, if you have installed all these services in your Ubuntu, so you are managing it, right? You are configuring it, and you are starting and stopping the services. But suppose you are using in companies, you are using Cloudera or you are using Hortonworks, right? So the Cloudera manager or Ambari, these are the services which you're using, starting and stopping the services. So these are the tools which is used to management of your all this Hadoop and resource manager, node manager services, or your Mapreduce services, HBase, Scoop, everything you can manage everything through the Ambari. So for cluster provisioning things, adding a node in the cluster, removing the node from the cluster. So Hadoop admin and Hadoop infrastructure management things you can do through the Ambari. Okay. So Drill, Presto, these are the some SQL DB engine. Okay. This is proprietary tool of the Mapper. Okay. So Apache Drill is a SQL query engine, and the similar tool is like a Presto is there also. That is a SQL query tool. So there are many more tools are there which is providing on top of your SQL database, right? Like Hive data, right? You can manage through the like you can integrate. Okay. Apache Spark is a processing engine. Okay, so that is the faster processing engine, right? It is used in memory computation. So everybody is using nowadays the Spark, but Spark needs programming, and completely is either Python, Scala, or Java. Spark is written in Scala itself, okay, and Kafka is written in Scala. So Scala knowledge, if you have, that is good, right? If you want to if somebody is asking to work on the Scala project, so that time you know the Scala. So Scala is similar to Java because it's using same JVM. Okay, for running the Scala code, we need a same JVM of Java. Okay, but Scala has its own compiler. Okay, so either one of the language is fine if you know it, or when you get a project, according to project you can learn that language, okay, for the Spark. But initially, if you want to start the Spark, you can learn with the Spark with Python. PySpark you can do. So basic understanding of Python will give you the how can you work in the Spark. So Spark has different modules are there. Spark core is a base module that is providing the transformations and actions. On top of the core module, we have a Spark SQL, Spark Streaming, and Spark Graph, and Spark Machine Learning libraries. But generally, we are using three modules: Spark Core, Spark SQL, and Spark Streaming. Okay, so Spark Streaming is providing the real-time data processing, and Spark SQL is providing the batch processing. Like you can read the data from the different sources, file system, SQL, NoSQL databases, and you can write the data to those target. But when you are working in the real-time data, right, when the data is coming through the streaming sources like REST services, Kafka, so you can write a consumer, right, in the Spark as a Spark streaming code, and there are the two types of streaming is there, the D stream and the structured streaming. Okay, Solar is indexing based searching tool, online search database. If you have heard about Elasticsearch, that is a REST based services tool, right? Like basically internally store the data in the REST JSON data. Okay, but Apache Solar is also similar online search tool. Like whenever we want to make it our search faster, okay, so it is the kind of database, like, but it's using its own indexing mechanism to read the data, right? So Apache Solar is also used in some companies, so they ask the knowledge of Apache Solar. Okay, is it clear so far, right? What is about all Hadoop ecosystem component? Okay, so some of the things I have already discussed. Okay, so I will be going little faster. Okay, so anyone has any question can ask anytime. Is there so far any question related to the fundamentals of the big data as well as ecosystem? Okay. Okay, thanks. Okay, so what is Hadoop architecture? Okay, so it is more in detail. Okay, so I have already prepared the notes. You can go through it, understand more, because I will be showing more like a practical hands on the commands. Okay, so I will be just going through the little faster. Okay, so name node and data node. So, okay, I already discussed about the master node. So wherever name node, we can keep it resource manager on the same, or we can keep it separately, separate node as a resource manager node. Okay, but data node and the node manager will be on the same machine. Okay, so wherever the data is processed, then the Mapreduce will be processing the data. Okay, so blocks, basically block is distributing your data into the number of blocks in the different nodes. So that is basically the block is a physical copy. Okay, the block is a physical copy of the data which is stored on the multiple nodes. Okay, so when you are reading and writing data, so the data will be stored in the form of blocks, and that will be handled by the name node. Okay, so name node will be controlling how many number of blocks and which data node it should store. So those information will be stored in the name node. Replication management, like every block has one replica copy. Okay, so this depends on us, like how much replication factor we want to keep it. By default is the replication factor is 3, but if you want to change replication factor 5, 6, or 5, 7, you can manage it. So generally the rack awareness concept is there. Next is coming the rack awareness. So when we are storing one block copy here, so 2 more copies will be there on the different nodes. Okay, so one node is down, data node is down, so other data node, the block copy will be read. Okay, so that is basically the replication factor. Because in the Hadoop file system, we are talking about the disk space is not issue for us, right? Because we are using use cluster, right? So, but important thing is a high availability. Suppose if I'm not making it this replication factor, I'm keeping it the data only on one node, and that data node is down, I will not receive my data back, right? So high availability is important than the storage of the data in a multiple disk, right? So the data block replication is there. Okay, so what is the rack awareness? So rack awareness, okay, real-time cluster. Okay, so basically, see, cluster depend on the data size handling. So generally, this question is asked, right? How much data size you are handling in your project? So I roughly say, suppose you are saying, okay, 500 GB to 1 terabyte data you are saying, or you are saying 10 terabyte data per day. So depending on the data size, okay, you or cluster will be like your size will be defined. So there are some fixed number of calculation is there, right? You can say, okay, so I'm having this much of data size processing every day. So if I have a 10 node, so if one node is having a 2 TB data, so 20 TB data is processed at a time, right? But 20 TB will not be used whole, right? So some data will be some size of the like 20 nodes will be stored in the some metadata or some other information. So that way we can calculate. So I say, like you can say the 10 node cluster. So you can say 10 node cluster is good for 500 GB to 1 terabyte data. So you are keeping it the variation. You are not saying exactly 1 TB data you are getting daily basis. You are getting the data 500 GB to terabyte. So you are saying some data is coming from the file system. Some are coming streaming sources of data like click streaming data. So mostly the data which is coming as a real-time data, then the size of the data will be more, right? Rather than the batch data. So batch data is coming like a 1 day, 100 files are coming. Okay, or if I'm saying the data is coming every second, every 10 seconds, the data size is more, right? Like I'm saying some clicks data is coming. Suppose this is a website and I'm doing the multiple clicks, right? So when I'm doing a multiple clicks, right? So the data is coming that are real-time logs data, server logs. So that data will be more. So depending on the data size, you can say the cluster, okay? So this cluster will be managed by the big data infrastructure team that will be managing the resources for the cluster. Okay. So in the rack awareness, so rack awareness means like generally I can say I have a 3 node and I can keep it same copy in like either all three different nodes I can keep it. But why it is not good? If I say if one block is stored in a one node here and other block is a one node here and one other block is stored in the other node. So if this node is down, so this block will be accessed, but it will take time, right? So the good rack awareness policy is you keep it one block copy here in one data node and the same copy you keep it in the another rack in the two different data nodes. So what will happen? Suppose this rack is down, so it will going to access this rack, and this rack also first node is down. So second data node, it will access quickly because that is an adjacent node. Okay. So the good rack awareness policy is like you keep it one block copy in one node in a one rack, and the other two block copy you keep it in the two adjacent node in the same rack, in the rack 2. Okay. So there are the multiple, this is basically defined by the some script is there. So you can configure that script. Suppose you say, I want to keep it all block in a same different node and different rack. Okay. So the good policy is you keep it one block, one node in one block. If this is down, it will access the second rack because rack has no reliability, right? Maybe one rack can be down, right? But second rack can be down also. So in that case, we will increase our replication factor 3 to 5. So in that case, we will do one node here, one block, one node, and second rack, two adjacent node, and the third rack again two adjacent node. So that way we will manage the 5 replication factor. If you have more replication factor, 7 you can do. But the policy will be like this. Okay. Like one rack has one node, one block copy, and the second rack has the two adjacent node, two different block, right? Okay, so that way we can store. Okay, so Mapreduce architecture. So map task. So mapper is having the map task. Okay, and map task is nothing but it is splitting the data into mappers, and record reader, right? Actually, there are the two more concepts are there. After once your data is converted, right? So there is an input split is there. Okay, input split and record reader. Okay, so first, like when your data is coming, right, by mapper is splitting data, so it is creating an input split, and input split is creating a record reader, and then the data is given to the shuffle and sort. Okay, so I will show completely this MapReduce code, then you will understand more clear. So combiner is concept is there, partitioner there, reduce task are there, shuffle and sort process is there. Okay, and different types of input and output format there. So in MapReduce, when we are reading the data, so there is a one input format. So if I say I'm reading a text file, so what is the input format for that? That is a text input format. Suppose I'm reading a data in MapReduce job from the SQL DB. Okay, so then the input format is called DB input format. Okay, so similar to the DB input format, there is an output format also there. So when the output data is generated after the reducer, okay, so initially your data is splitted, generating the mappers, and shuffling process is started, shuffle and sort, and aggregate the values by key, and finally reducer is getting all output in a one single file. Okay, so this whole process, like final data is a output format. So what is output format? Again, the output format could be any type. So when I'm generating a text type of data, my result, so I will say the text output format is there. That is a default. But I can write the data to the SQL DBs through the through like MapReduce job. So MapReduce job can do the all type of things we can do, right? We can read the files, we can write the files, or we can read the input data from the database, or write the data to the database. Okay, but for that purpose we don't write the MapReduce, because MapReduce job writing a huge lines of code, right? So we have to write one mapper file, mapper class, reducer class, and driver class, right? Okay, so yarn, yet another resource negotiator. Okay, so that is basically managing the resources, name node, resource manager, job node manager, and the resource manager. Resource manager is managing the resources as well. So scheduler is there. Okay, there are the three types of scheduler, right? FIFO is there, first in, first out. So whichever job will come first, that will be executed first. And there is a capacity scheduler, and you can define the fixed capacity, right? So every scheduler will be getting its own time. So that way the scheduler will decide. Okay. Application manager, like when we are interacting from the resource manager to node manager, so application manager comes in picture. Okay, so application manager is a mediator between the resource manager and the node manager. So application manager comes in picture. Okay, so these are the features of yarn, right? Scalability, multi-tenancy, right? Compatibility, right? So these are the, you can go through it. Okay. Okay, let me start like a Hadoop installation thing. Okay. Any instance you can, even in the T2 micro also you can install, it's not a problem. Just I need to create a one instance. So you have to connect this EC2 instance. So I'm using a MoveX term. You can use putty or anything you can use. Okay. Creating a new
Let me
session.
use EC2 versus EMR.
EC2, EMR itself is a EC2 only. Okay. See, EMR is like whenever creating a EMR cluster, so it will be taken from the EC2 only. Then it is giving to you the EMR. Okay. Okay. Difference you are asking, right? EC2 versus. Okay. EC2 is just a machine, right? Like I have created one Ubuntu class. Okay. It is not having by default Hadoop Spark. Nothing is there. It's just like a empty machine, right? Like a virtual machine. I got it. Okay. Just I got a machine. Okay. But if I want to install, I have to do everything from the scratch. Like I have to install Hadoop, Hive, Scoop, everything you have to do manually, right? You have to create your own cluster. But EMR is a ready-made cluster, right? EMR is just like a Cloudera. Like Cloudera, when you install the Cloudera on your machine, so you get everything in the Cloudera machine, right? Cloudera CDH or CDP is giving you everything is ready-made. Okay, but Cloudera, you are done. Cloudera is okay. So for some time, like Cloudera is free, right? 60 days trial is there. You can download it and you can use it. Or some community version, you can use it. That is free for the non-commercial purpose. Okay, support you will not get it in the Cloudera. Okay, so you can install. So everything you will get it. But if you want to use it in the cloud, right? Because in the Cloudera, you will not be using the cloud features, right? You can't use the cloud-based services. Okay. So in that case, you go EMR and EMR cluster you create. Once you create a EMR cluster, you go here EMR and create a new EMR cluster. So everything will come automatically. Whatever, like you just say here, create cluster EMR. Okay. And now I'm creating a EMR cluster. And here I'm telling it what I need. I need Hadoop, I need Spark, I need HBase, I need Pesto, what I need. Everything it will provide you. This is a new version of EMR. So, but it's a paid, right? When you running a EMR, spin up the EMR cluster, so EMR cluster will be charging you because it's not giving you Hadoop Spark free, right? Okay. So generally companies like they use EMR also if they want cloud-based Hadoop Spark solution and they don't want to use Cloudera, right? Okay, the Cloudera you can use in the local, right, on premises, right, network. Okay, but in the cloud you want to use, you have to go for EMR. But what the way we are doing EC2 one, this is everything we will do manually here. Okay, so EC2 you have to installation you have to do. Suppose you have to do some Jenkins, Docker. So it's like a machine, right? Like VirtualBox. I have configured this Ubuntu. So you are manually here, it's taking your system RAM, right? Because this VirtualBox is taking your system RAM, and on top of that, you are installing this Ubuntu. Okay. In this Ubuntu, you are installing the Hadoop, everything. The same thing I'm doing here, EC2. Okay. But EC2 will be paid also when it is crossing the limit, right? 750 hours, disk storage, right? Even if you are closing this, if you are stopping this instance, but the storage charges will be there, but that will be very, very minimal, hardly $3-4 a month. Okay. So, right. So you are using Ubuntu on EC2, right? So it's just like a CPU machine, right? You got a one machine of one particular OS. That's it. Okay.
Arvind, if EMR they give some default softwares, right? Other than that, we can able to install whatever
Yeah,
we
we can
want.
do. Suppose I want to, generally what we do, like suppose Airflow I want to use. Okay. So instead of using the EMR, you can do in EC2 and then you can integrate. See, anything you are doing in the AWS, EC2 or any service you can easily connect, right? You know, right? Boto 3 is there. You can get any resource in the Lambda, right? So Lambda is a service which can access any of the service. So in EC2, you have installed Airflow or you installed Jenkins or you want to use the like your EMR Spark job, right? You want to schedule with the Jenkins, you can do that. Okay. So you have to schedule it, right, through the EC2. So EC2 can access EMR, right? But that EMR cluster is a separate EC2 nodes are there. That is dedicated node for Hadoop Spark cluster. Or if you want to do the installation, you can do itself there itself also, because that is also EC2 node only, the EMR cluster. Okay. So there also you can use. Okay, so now I'm connected my EC2. Okay, so I just use my PAM file. So PAM file I have already, it's a key value pair file. Okay, generally when you are creating a new EC2 instance, you can create that time, or if you have already created, you can use it existing one. Okay, so now I am in my EC2 machine. So here, right now nothing is there. It's my home Ubuntu. Okay, so Ubuntu is a default user. Ubuntu is a user of EC2. Now I want to install the Hadoop here. Okay, so the same installation you can do in a local, you can do in a local Ubuntu VirtualBox, but already I have Ubuntu Hadoop. I cannot install again, so that's the reason I'm showing here. Okay, first we need a Java. Okay, first we do sudo apt update. So here is a very quick, like we have configured this Ubuntu. Otherwise, if I'm doing Ubuntu in my VirtualBox, it will take 30-minute time to install Ubuntu, right? So I'm doing sudo apt update. 5 minutes will take. Just we have to just run the command, so it will install. And then we need a JDK. So Java 8, even you can use Java 11, but not go for more than Java 11. For practice purpose, good to install in the your own VirtualBox, so that you can do command practice. You can do Hadoop command practice, Mapreduce code. List of software need to install in the sequence. Yeah, I will mention it. So first we need VirtualBox. If you have done, the first thing is in the VirtualBox. Okay, so you have to install VirtualBox in the Windows. VirtualBox. Okay, or VMware workstation. If some VirtualBox, and then Ubuntu. Ubuntu you can choose 23.04 or 22.04, any version, and then you have to install like Chrome. You can keep it because because default browser in the VirtualBox is Firefox, but I have configured Chrome. Okay, so it is faster. Okay, Chrome you can do, and then you can install Hadoop. Hive you can do, Scoop you can do, HBase, okay, Flume, and then Spark, Kafka, okay, Scala also we need, Python we need, okay, we need other softwares like Mongo, TV, Cassandra, okay. And I have a ready-made Ubuntu VM. You want to use that VM, you can directly configure with all these all already there in that VM. So just you have to import and then you can use it. If you don't want to install one by one each thing, okay. But installation you do once, you will get the knowledge like how to install, right? So sometimes if you need it, you can install your own, okay. So better to go for that. Now we are installing the OpenSSH server and client for making it passwordless authentication. Okay, next is this step we will not do because we don't need to create a user. We will be doing we will be installing Hadoop in the default user. Okay, the default user Ubuntu is there. We will be doing in that. Okay, so this step we will not do. Okay, so this is a keygen. This is making for passwordless. So we are doing the keyless this password. So this is the authorized key. Okay, then we have to give the permission 600. So this is a ch mode permission. We are defining on authorized key. This authorized key we store here. Okay, and after that we will test once SSH localhost. Okay. Now we need this Hadoop. So there is I have to this wget command you should not use. You should go here official page and there we go to the release. So 3.3.3.5 binary release you go. So binary release you go here, and this is the wget you can do. Okay, so here I'm creating a one directory softwares, cd softwares, and I do wget. Let's see what. So it will download this tar file, and then I will extract the tar file. So I will verify it, ls. Okay. It is extracting this tar. Okay, so we will get the Hadoop 3.3.5 folder, and that one we have to set our bash RC. Okay, so now I check it. So I will remove this tar file if not needed. Okay, now I go to cd Hadoop. So I will get this complete Hadoop libraries, right? Complete bin and all like live, everything is coming. So now I go to and set the Hadoop home path. So I go nano bash RC. This is my bash RC. It's the same like you do in the virtual box locally because it's a Ubuntu machine. So Ubuntu machine like same steps because I'm showing because of mine is local machine is already installed. Okay. So we go to the again installation steps. Here we have done so far here. Now we are setting this home path. This path we are setting. So but here we have to change this home Hadoop. So here we have to change because this one is using this Hadoop, but our one is Ubuntu is a user, and then I created a software, and my 3 point the version is
3.3.5.
3.3.5, yeah. So 3.3.5. So I will change it to 3.3.5, and here is a one small minor change is there, equal sign. Okay, copy this, and here we will paste it, and after that we will Control X, Shift Y, enter. Okay, and source command to apply our changes. Okay, once it's done, so we have sent the Hadoop path, and this is all done. Okay, so Hadoop env sh file, we have to add this JDK path. Okay, so our JDK is in this location, USR lib JVM. So Hadoop is using the Java, right? So we have to provide it. So I will open this file. So I have already set the home path. It is not opening the correct. CT etc. So we have all files here. So vi Hadoop env. So this file anywhere we can paste that Java home. Already here is the Java home. So here we this is the Java home path, export. So one by one, we will open all the files. Configuration file we have. So total 4 configuration file, core site, HDFS site, Mapred, and yarn site. Okay, so these 4 configuration file, we will update the configuration. So first we start with the core site. So we will remove this configuration tag. We'll copy from here core site.xml. The core site is this one, but here we have to change the username here. So this thing we have to change. We have to change here Hadoop to Ubuntu. 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 Second one is hdfs site. Here also we need to change the username. So here is a name node directory and data node directory. So it's a single node, right? So here we are creating a name node, and name node will store in the name node directory, and data node actual data will store in the data directory. And the replication is defined here. It's a single machine. If you keep it 3 also, the replication blocks will be on the same machine. So generally, replication factor 3 is used in the, like when you have the 3 node cluster or the larger size of cluster. So here I have to change Ubuntu. So this username you have to change whatever username you use. Suppose your username is your on name, so you should use that one. So just you change the username here and add this configuration. Next is Mapreduce.xml. Site.xml. Okay, so here I will add Mapreduce.xml. So here is no change. You can directly paste. View, and last is yarn size. So DD is the option to delete. Okay, in the VI editor. So this is yarn site.xml. Everything is done. HDFS name node minus format. Is a problem in the bash RC. Because it is not picking up the Hadoop. Slash home Ubuntu. Directory 3.3.5. Home Ubuntu softwares Hadoop 3.3.5. Node recognizing HDFS. pnb.sh. Here is Java home is correct.
I think there's a place to put the Java home here. I saw a place where they wrote export Java home.
Yeah, export Java underscore home. What
If you
you're
go down, if you go down 1, 2, 3 paragraphs, you will see a place where they say export Java home. No, you've passed it. No, you've passed it. Up. I saw it up.
down? Java
was
home
up.
we can type it anywhere. We can write it anywhere. It's
Okay.
yeah, it's not a matter. Okay, let's try this. The and that is generally it's a it is not recognizing is hdfs. Generally, when your path is not set the bash rc, so then it should say hdfs name node format.
Could you try updating the Java itself?
Java what?
Update.
Okay, sudo apt update.
Yes. Let me know. How's it not working?
Sudo apt update.
Yeah, sure.
Sudo apt.
Space. No, no, no.
I think
There's no minus there.
but sudo apt update, why it is not working?
That's what I'm wondering.
Yeah.
Yeah, it's working now.
Are you
Okay.
not supposed to say? Are you not supposed to say hdfs dfs name node minus format?
No. That command is same. hdfs name node format. SDFS and then name node format. Okay, so this
Okay.
command is correct. SDFS name node minus format. This one, see, SDFS name node minus.
Okay. No, you're correct, sorry.
This one's working.
It is not recognizing. SDFS is not. Okay, so this is the last step. Okay, once it's done, you will be starting the start dfs.sh. Also data node, name node, and secondary name node service will start. And when you do the yarn sh, then resource manager, node manager will start. Or you can start all the services. So start -all.sh you can do. So start -all.sh will start all the services. So you will see name node, data node, secondary name node, and node manager, resource manager. If you want to see the UI, you can use this UI to see the complete Hadoop cluster. You can see what you installed. You can see. Okay. I show in my local. Okay. Once it is installed, so you will be able to see. So when your Hadoop services should be running, if your Hadoop services are running, we can see browse file system. So the entire file system, right? My Hadoop file system, I have created directories, files, okay? In the directories having the files. So we can see navigation here, but it is just for view. Okay, so when you want to run the Hadoop commands, so you will be using the terminal. So you will use the terminal and then you will use the command to do. So when you want to do hadoop fs -ls/, right? So this is just root directory, right? You want to see all the files and everything the same, whatever you are able to see here, the same thing you can see here through the terminal. So it's a virtual directory. So you have to give a complete path. Suppose you want to create a directory, hadoop fs -mkdir /workshop. So this directory I want to create, it is creating empty directory. So when I want to create a multiple directory together, so I can do test1, test2. So I have to use -p option. So it's a Linux option only. So just create a multiple directory together in the Hadoop file system. Again, you want to check your directory. So hadoop fs -ls/ you can do workshop1, then you will get it test1, and test1 is having the test2. So which directory you give, you can see inside the directory, you can see the content. Okay. You want to write a file, copy a file. So there is a Hadoop. So how can you see like how many commands are there? Hadoop commands. So hadoop fs you type. So then you can see these are the list of commands. Okay. So you can practice the command, right? Append to file, cat command, chgroup, chmod, chon. Checksum is basically every file having its unique checksum. So checksum is generally validate the file is same or not. Okay. So the checksum is like one checksum code will be created, and that checksum will be used to verify without seeing the content of file. We can verify by checksum. Okay. So that checksum is used for that purpose. Chgroup, chmod, these are the command for the like changing the permissions on our group, change the group, right, over that purpose. Okay, first we see the basic commands. So I just done the ls command, and I have some file here. Okay, I have some, suppose this tsv file. I want to copy into the Hadoop file system. So hadoop fs -put you can do and say employee tsv. This is a file, and then you can give the location of your target of Hadoop file system. So you did workshop1. So my file is copied. Or another way is copy from local. So copy from local. So here you are saying you want to copy the file from your Linux file system, local file system to Hadoop file system. So copy from local command, and you can give the source and target. So source path will be your local path and target will be the Hadoop path. When you do enter, because this file is already present, right? Because last time I copied the file, right? So it is saying it exists, but still you want to overwrite the content. So there is a -f you can use for forcefully write. So forcefully write you can do. Now it's written the forcefully, like it is overwritten. The content is overwritten. Okay. So generally sometimes I want to override my existing content of my Hadoop file system file. So either you can use put command and copy from local. Okay. I will give the history of this command so you can see all the commands. Okay. So copy from local is like copying the file from local file system to Hadoop, or you can use put. Both are same. Okay. Another command is like suppose you have a file in Hadoop file system, but you want to get into your local file system. So you can use either hadoop fs -get, and you can give the path workshop1 / employee tsv. This file already there, right? So you copied this one employee tsv, and then you write into the local. Local, you can directly do the dot, that will get the file in your local, but this file is already there, right? So you will get the error, file exists, right? So here is also a way, like you want to override your local file, -f you will use or forcefully write. So now it is overridden. So get or copy to local. Another command is copy to local. Copy to local. This is also same as a get.
So the local drive is not your, it's not your C drive, it's the virtual drive.
Oh, here is a Ubuntu is my system, right? So local means Ubuntu local. Like
Okay,
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 this is ls you do, this is the local files,
okay.
right? So here it is coming. Okay. So file is already exists. That's the reason it's giving error. So I have used this -f. Okay. So -f is very careful, right? To you use, right? Like generally it will override your local or Hadoop file, right? Okay. So whenever you want to use it, just use carefully. So this is command, right? First we have seen mkdir. So Hadoop fs minus mkdir. Second one is a Hadoop fs minus ls / then you can give any directory, workshop 1. Then Hadoop fs minus put command or minus copy from local, and we'll give the source path. Source path is my local file. I say employee. So you have to create this file because in my system it's already there. So then you are copying into this workshop directory, or you can use Hadoop fs minus get command or minus copy to local. Then you give the here workshop 1 / employee file, and then you will be getting the local dot. If you want to use, you can use -f option. Like this is the additional one, right? When you want to override. So you can use here, after the command, you can use -f. Here also you can use -f. It is needed, if it is needed. Okay. Suppose I have 2 files in my local file system. I want to concatenate those 2 files, like this 2 file, hello and this one. So there is a Hadoop fs minus append to file. Okay, I can give employee and hello, and then I want to write my workshop 1 with the different name. I say employee new. Okay, so some file I'm creating new. Now I want to see the content of this one, Hadoop fs minus cat, and I say workshop 1 and say employee under new, this file. So it is having the content of these two. So one file is this and one file is this, right? The 2 files content I'm getting. So this is a command for append to file, like merge the content of 2 file and write into the Hadoop file system. So append to file. And Hadoop fs cat command is to see the content. Cat, and then you can give your this file location where you want to see the content. Okay. Another command is, suppose you have 2 files in your Hadoop file system and you want to merge it, and single file you want to see in your local file system. So when you say Hadoop fs minus get merge, and you say you have workshop 1 / employee new, and another one more file is the workshop, but Hadoop file you have to give complete path, workshop 1 / the same file I can give. Okay, what I need, employee, TSB is there. Okay, so this one, 2 files are there, and I want to get in my local with the name. I say
Dots.
employee TSP new. Okay, so just any name I'm giving, so it will create in the my local. So if I do ls here, so I'm getting here the file is new, this file. So I will do cat. I will do here simply cat employee TSP new. So you will see the content of all Hadoop files. This is one file and this is one file. So I merge it and I'm getting into the local file system. Okay, so this is the get merge command. So this get merge, you can do from the two files in the Hadoop file system, and then you can merge it. Okay, so what other commands are there? Okay, so if I do hadoop fs, other command is like a truncate command, test command, text command. Okay, so touch command is basically, okay, set rep we see first. Okay, we seen that replication factor is a 1. Okay, so I want to change the replication factor, hadoop fs minus set rep. Particular file replication factor you want to change manually, command line. Generally, the file system replication factor is 1, which is I set it in the configuration file. But that is applicable to all file, but particular file you want to change. Okay, so then we can give, I say set rep, I say 3, I want to make it 3 for a particular file, or directory you can do, but you have to use minus -r, you have to use recursive. So this will be applied to all the files in the directory. Okay, and -r is for the recursive also. Okay, -r for recursive. So I'm giving here workshop 1 and employee TSP. This is my file. So now the application C is set, right? Now I want to verify -ls workshop 1. Just in this directory, I want to see this employee TSP file is set 3. So now the 3 block copy will be replicated, right? So previously only 1 block, now the 3. The 2 more copies will be replicated for the same file. The 2 more copy. So this is set the replication factor. Okay, so other command. So these are command, basic command, right? Just we know, right? Like, okay, find command. Suppose how I want to search it. How we can see the size of the files, like du command is there. So hadoop fs minus du, hadoop fs minus du, and then I can give the it is telling about the sizes of the, okay, and the directory in the this file is having this size. Okay, in this directory no count. Okay, so it is, and dus, 2 commands are there. So total you want to see, you can see it here. Okay, and if you want to see individual files and directories, so you can get it. Okay, so when you do hadoop fs minus ls workshop 1 workshop, so
Doesn't this remind us of
2 files and 1 directory is there, right?
just a comment? I said this reminds me of before Windows, how we used to type commands in DOS.
What you are saying, Windows?
No. I said all this, the typing of commands, the CMD command, the command Windows. That was how DOS was operating before Windows operating system, isn't it?
You are saying these are Linux command, right? These are Linux only, right?
Yes, these are Linux. They're insisting in typing. Everything you have to type on the Linux, because it was done this way in Windows, in DOS. That's disk operating system before Windows came in.
Okay, so if you want to do in Windows, right? You mean to say, right?
No, if you want to do this thing graphically, so that you can cut and paste, you can do all these things we are doing graphically, as we're doing in Windows. It's not possible here, I don't think.
See, programmatically is a one way that I will show, one hdfs Java API, right? So programmatically you can do, but you will not be using command. Internally,
because this command is tedious. It's so many. Each time you want to do something, you have to remember.
So programmatically is like you will be writing a some Java program, and I want to copy like 100 files in a directory to the 100. Manually, if you do here, so 100 times you have to run copy command, okay, or you have to give right wildcard character you have to use, right? So for that, we want to make it automate, right? Like, okay, some automation things I want to do every day. The files are coming. You don't want to do manual activity, right? Every day you are transferring.
Simplify it.
Okay.
Yeah.
So for that, we can write some Java program, right? So like we can write a copy a file, create a directory, create a file. So this kind of program we can write. So program means it will read your input, and based on the input, right, what you want to do, it will do. Like you are saying, copy the file from this directory, and multiple command, like not only like in one single program, you can, this is I created separate, but you can keep it in a one single, like first you create a directory, then you are copying the file, okay, or creating a file, and then you are not using the file, you want to delete file, or you want to like something list you want to do, you want to read the file, or you want to rename the file, you can create in a one single program. And once you run your program, right, so everything it will be do in a single shot, right?
That's
Okay.
much, yeah.
So
For
it's like
practice,
a batch, right? You know, right? In the Windows
batch
we have
processing,
batch,
yes.
right?
Batch
And Linux
processing.
we have shell scripting we do, right?
Yeah.
So even you can do the same things if you write this command in the shell script, so it will
Correct.
perform one by one. See, automation things you can do with anything. Either you can use Linux shell scripting or Java program, Python program, anything you can write. But first thing is like individual command, what it is working. And you should know the particular command, like which is used, which command is required, right? Suppose
Right.
you're given a task, right? First create some new directory for a new date. Suppose you have arrived 100 files today, correct? So you have to write a logic generic way. Today is a date is something. So your date folder will be created by today date. So you will be writing a logic for the creating a folder name, right? At a date folder name. And then once you create a directory with the folder, then you will say, okay, 100 files which came, which arrived in the local, all you want to move into the Hadoop file system. Then after you want to do some processing on those files. So everything you can write in the Java program. Okay, so this is a code like creating a file, copy a file, rename a file, read a file. So you can do you, because this Hadoop file system access everybody is not getting, right? Okay, as node access you have, you can run even the command, but sometimes if you are not having a chance to do run this Hadoop command locally, so there is a curl API is there, REST curl API. So you can use curl 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 command in the Linux is there, curl any REST API command, curl -i, and then you can give HTTP command, you can give REST service command. Like this HTTP command you can run. I will show how to create a file, directory, same thing. So there are the different ways of doing. You are doing the same work. One is you are doing the directly on the command line when you have access on the edge node on the same machine. But when you have access not there on the edge node on your local machine, you have a remote access, you will use curl command. And when you don't have the access of these two, you can write a program, and this program you can run from your local machine and it will do everything. Okay. So like what is the use case, right? Like you have how many three different ways are accessing the HDFS. So HDFS is providing the file management system, right? It is providing how to manage your files, right? How can you copy whatever you do in the local file system, right? In the Linux file system, you are doing this copy, remove, right? All those activities, either you can do programmatic way, you can do either you can do the programmatic way, or you can do any way, right? Or you can use REST curl API. Okay.
Okay.
Yeah.
We'll probably need to know, learn how to write the scripts.
Script of shell script, or like which one is script?
Shell scripts.
Yeah, shell script also you can write, right? Shell command you write, and you can write this Hadoop command, you try it, like you can do the same with the shell script. Okay, because this is also shell script, like Linux command we are running, right? On the
Right.
$shell. So same command, if you put it in the shell script, becomes automation, right? Like all set of command will run one after one. But here you are running one single command, and interactive way you are getting the result, right? You are getting the result. Same like a Python shell you are doing, or you are running a Python file. When you are running a Python file, all the commands in the Python file will be executed one after one. But when you are running a Python shell, right, so you are getting an interactive shell. So interactive shell, you will get the immediate one command at a time you are running. Okay. Okay, so what I was saying here, okay, this Hadoop commands, more Hadoop commands I should cover. I have all list of commands, and I have prepared document. You can use it, that document also. I will share it. HDFS tutorial. So these all things will be repeated, okay, because the fundamental concept and it is the same concept again and again, okay. So you will see every time this same concepts are coming again and again, okay. So here is the practical of the command. So since this one satrap command, okay, remove change groups, change mode, right? Ch mode, ch on, 3 commands are there. So ch group is changing the group, right? You want to change the group. Ch mode is changing the permissions, right? You can change the permission. So ch mode command we can use. Okay. So if I want to do hadoop fs minus ch mode and I say 777, right? User group and others, right? So I can give workshop on and I want to see. So it's a simple, if somebody knows the Linux command, so then he can easily understand this command, and then just only I'm adding the hadoop fs. So hadoop fs is for Hadoop file system, and I can use the respective commands I can use. Okay, so ch mode, if I want to change the group, ch on command, and some more commands, like if I want to create a one empty file, so touch command is there, hadoop fs minus touch. Okay, and I say so this is created. Truncate command, suppose the file, existing file I want to truncate. Okay, so some file I have a content, okay, and I want to do truncate, hadoop fs minus truncate
So what is this touch command now? Minus touch.
minus search.
Yes.
Oh, this is
Okay.
just created empty file. Okay, if you see
Oh.
here,
Okay.
generally touch is in the Linux we use for creating an empty file. Workshop one, new file, but there will be no content if I empty file. Suppose I want to create a file first and I want to overwrite this file with the local file content. Okay.
Okay.
So there is nothing there. Okay. So when I say truncate minus W, I want to truncate. Okay, I want keep it only 3 characters, and I say so some file which is having the content. So this one I take it, employee underscore TSV. Okay, so it is length, now length is become 3. So first 3 characters you will see. But it is changed in the existing file only. It is not creating a new file. It is changing the file itself. Right. So sometimes you have requirement, you want to modify the existing file. So you can see, so only 3 correct, 100. Okay, so rest of the all will be removed. Okay, suppose you want to remove a directory, hadoop fs minus rm command, right? I want to particular file, or you can do all the content you want to do. So you can do RMR. So RMR will be like entire content, right? Okay. So if I workshop one I do, so it will be recursive. So everything is gone from the. So it is saying no such file directory. So everything is like deleted, right? Okay. So it is going to the trash, right? Trash is there. So this Hadoop is managing its own Hadoop file system trash, right? Like local file system having trash, like generally
Okay.
file delete. So it goes to the trash, right?
So you can recover them if you need to.
Yeah. So if you want to recover it, so this trash, but this trash is not by default, like you have to configure it. Okay, so there is a configuration we have to do in the core site.xml file. Okay, so we have to do the entry, and then we have to, this trash once it comes in the my user directory. So it will automatically create a one folder /user, my username and trash and current. And after that, whatever your files will going, it will be going into the trash. Okay. So it will be going to it will be creating some date folder, and it will create a particular file will be. So now you want to get back. So you can use the copy command. So CP command is used to copy from Hadoop to Hadoop cluster. Suppose you have two directories. One is okay, I say I have one is workshop directory. So I'm creating. And I check in my workshop, and I want to copy some file from the workshop to workshop one. So here I say one hello.txt file is their workshop. I want to copy to the workshop one. So when you are doing copy to copy from the Hadoop to Hadoop, so you use Hadoop CP, Hadoop fs minus CP command. Okay, and then we give the source path. Then you can give the target workshop one. So this file will be copied there. So if I want to use MB, it will move it. So I can see cat workshop one hello.txt. These are the simple command. Just once you see this hello world is coming. So this file is copied. Okay.
Can
So
you,
this
can
way.
you, can you see the content of the trash if you want to?
Okay. Hello fs minus ls. So what is the directory
Yeah.
path?
For the
This
trash.
is, okay. So this current directory you go.
So you can copy from it if you need to.
So in this workshop one, if I this is copied. Okay, so one this folder, same file which you deleted, it is there. Okay,
So we can copy it back if you wanted to from that.
so you can do Hadoop fs CP, you will use CP,
Yeah.
and then C minus CP, and then you have to give this complete path,
Directory, yeah.
because this is the source path of your file. Okay, and then you say here the workshop one.
We'll bring it back.
Same name, this file is the same name will be, if the file exists with the same name, so then it will give the error, right? File already exists.
Right. Okay.
Okay, so,
I get
so
it.
if you want to clean this trash, there is a expunge command is there. Okay, Hadoop fs minus expunge.
Expunge. It's gone forever.
It is just expunge. So it is saying, so but still it will not delete permanently.
Oh.
It will be moving, right? Now if you see the trash, okay, so how it shows trash. Okay, so if you see the trash location, this is the trash. Okay, so now it is there or not in the trash. Now it is not there, because what it did in this current folder, it created all the files in a, okay, this is also not there. So in the trash you see one single folder is created with the date and time stamp. It's 1104. It created this folder, and everything is moved into this one. Okay, so this particular file.
So even when you expunge, the file is still there.
Yeah, it's still there, but actually it is not directly there, right? So everything moved into the one folder rather than keeping it separate. Now, if you still want, so you have to give this location. You have to give this location.
I'll expunge it permanently.
Yeah, but expunge is just making it consolidated into the one folder, right? Like not keeping it separate. Okay.
Oh, I get it.
Okay. Cleaning up is doing, it's doing cleanup, right? It's doing cleanup, right? Okay. So okay, so this put command, mkdir ls, mostly command like head command, like first lines of and tail command is there. Okay, head and tail. Suppose you want to see the content of file, and so suppose you say add of particular file. Number we have to give. No, I think it will empty file maybe. Or what? Okay, cat. It is okay. So only. Yeah, add is coming actually. I didn't see here, right? 100 is there, the value. Okay, so it is there. So had means whatever content is there. Okay, suppose this file you want to open in the tail, right? So tail is basically generally we see the log, right? Okay, generally we see the log, right? Okay, I say hadoop fs minus tail, I say workshop, and I will add the content in this file. Okay, workshop 1 slash employee. So it is now in the tail mode. Okay, so tail minus f I have to use. Okay, now it's not ended, right? Its keep is still in the file, right? If you see, it's still in the file, right? It is still in the file. So further some more content come in this file. Okay, so it will be keep showing those content. Okay, so if I'm adding the some more content in my local file system, so I do hadoop fs minus append to file. Okay, some local file I'm taking here, tsv. Okay, so now I'm appending in this file workshop slash employee underscore tsv. Okay, so I have added content. Oh, I didn't use the one. Actually, I have done the, yeah. See, entire content came, right? So this is a tail command. Generally, we see the log, right? So this logs will be giving you keep appending the logs, right? So this is a tail command. So similar in the Linux file system, we use a tail, right? So we use that way. So your contents will be keep coming, so you can. Okay. Okay, now next I'm showing the Hadoop file system how to use through the Java API. Okay, so some more commands are there. I will give the list of command you can practice. Okay, so in Hadoop file system, right, we are using Java APIs, right? We are using Java APIs. So I have created some Java project. Okay, so it's a Maven Java project I created. I created project and I created this Maven type project. Okay, my project. Okay, and I can choose a quick archetype is a quick start. Okay, and I can create this project. This window or new window, I say new window. So I will get one Maven Java project. Okay, so this Maven Java project, I have to use the Hadoop Java API, right? So I have to use the libraries. So first of all, what I need to do, I have to copy the dependencies. Okay, so Maven we are using as a build tool. We are using Maven as a build tool. So I have to go to here pom.xml. I'm using pom.xml. So pom.xml, I'm using the Hadoop client, this jar. So we can use the 3 version or 2.x version. Okay, so this jar I will copy and I create the other dependency. So in my new project, this is my new project. In this new project, I have src main. So here I will create a package for the Java classes. So I will create a Java classes in this package. and pom.xml, I will add a dependency. So already this is the default dependency is given JUnit test cases. So I'm adding the one more dependency of Hadoop, and then I will do reload this Maven dependency, reload projects. So now you can write the Java classes in this project. So this is the first step. So you have to create a one Java project, Maven Java project, and add the Maven dependency for your Hadoop. Okay, because you are going to use the Hadoop HDFS Java API. So once you've done this, and then you can create a file. Okay, suppose I want to create a directory. Okay, just take this example. So first what I'm doing, I'm just writing a main function. In main function, I'm creating a configuration class, configuration, new configuration. I'm setting the default name node address. So my name node is running on 9000 port. Okay, 9000. Okay, for SDFS port is a 9000. Okay, so here I'm just using my location. I'm giving here, I want to create a directory. Suppose I say workshop 1. I want to create this new 1.2 directory. So workshop 1 is already there. I want to create new 1.2, or multiple directories you can give. As many as directory you want to create in the same path, you can create. So what I'm doing here, I'm just calling this create dir function. This create dir is my own function. I'm taking the path of file. I'm creating a path of the file. I'm taking a path of the file, and I'm checking here file system object. This file system is a Hadoop file system type. org Apache Hadoop FS file system. So for particular path, for this particular path, I'm setting my configuration. What is the configuration? My Hadoop location, my Hadoop HTTP location of the Hadoop. So my location is a 9000 port. So this configuration, I'm giving it to my this get file system. So what this method will do, it will give me one file system object pointing to this configuration. Okay, and particular path, which path I provided for this path, I'm creating a directory. So there is a Java method is there in the Hadoop HDFS Java API, file system.mkdir and directory path. So this path will create a directory. So this command will call internally the Linux command, right? Like it is, this Java method will be calling the mkdir, right? Method, like command. Okay. So you are doing programmatic way, but internally it is executing the command. Okay. So when I run this program, so it is accessing my Hadoop file system. It is accessing my Hadoop file system. So the thing is, your Hadoop file system should be keep running. If your Hadoop file system is not running, so you will get the connection host exception you will get, right? You are not connecting to your Hadoop file system. So here I just printed, once my directory is created, I just printed the message success. Like if I'm able to create a directory, then only I will come here, right? Success. And I'm just printing success. Okay, now I can verify. So I give in the workshop 1. So here new 1.2 is created. So new 1.2 directory is created. This is a directory. I want to create a file in the directory. So there is another function, another class I have written, create file. So every time I will use this thing same, right? Because the configuration part will be the same. Okay, so 9000. So I will be using the same configuration, and I will be giving a location, like I want to create a file workshop 1 new 1.2 with the name new 1.2 tst. So this file I want to create in my this new 1.2 directory. So when I'm giving this create file method, my file location, and I'm giving configuration. So first of all, I have to get Hadoop file system. So file system, I have to get it. So once I get Hadoop file system object, so there is a create function is there. There is a mkdir is there. Here is a create. So create will be basically creating an output stream. So this is a Java IO, input output stream, right? So input stream classes to read the data, and output stream classes are to write the data. So here I'm using output stream classes. So output stream dot write, I will write the data. Okay. So what data I will write? Whatever data I prepared here. This data can you read from some file also. Suppose you are reading the text file or something, you can read from there. But here this data I have generated manually, just I've created manually. Okay, so once you write the file, after that you can do the file array, this Hadoop file status. So you will get all the files path, right? So you will get the status of file means all the files path you can get. So you will get the file object, file status object, and each file status object have file path, right? So when I run this, so it's a simple program, right? Just Java API code. Okay, you can write Python code also, or you can write the shell script like your, okay, or command, through command you can do. So this is, in this particular file, only one file is there. So this is created. Okay, suppose I want to create another one more file with a different name. So I just change this and then I create it. Now the two files will come. One is already existing file and one is new one. Okay, I'm printing only one. Actually, here I'm printing new file 1.3. Okay, let's see here. Workshop 1. Okay, new 1.2 we give in the directory. New 1.2. So here the two files are there. New file 1.2.txt and new file 1.2. So this I run 11.20, this I run 11.21. So just in 1 minute difference, I run it and I got it file here. But both are having the same content. If you see the content, hdfs minus cat, then you can give the .txt. So it's the same content. Okay, so whatever content you written here from the file. Delete file, you want to delete a file on a particular file path, you can delete file. So it will delete. So I have a file already, new 1.2. So I want to delete one file. So I can run. So this is, I'm testing for one by one, right? But you can do all this one in a one single program also, you can write. One after one you can do. So once you get this files system object, right? This HDFS, like file system object, you can do whatever you want because you got the complete access of your Hadoop file system. You can copy, you can rename, you can delete. So every method on this HDFS object, when you say HDFS copy, HDFS create, HDFS delete, HDFS rename, so different APIs methods are there. And these APIs methods are like in the Hadoop APIs is there, file system. So file system object we need first, and then we can call this APIs method and provide our input path. Okay, so when I say this, then I will not get the second file because the second file, this one is deleted, not a file. Okay, so file is not there. Okay, so I can rename a file. Suppose I have a two file, one is a hello.txt and I want to change to the name to this file. Okay, so I say, I have a file, new file 1.3. So new file 1.3 file, new file 1.3. So even I can check the file first, it is present or not. I can use this one, file exist. Okay, through file exist, I will verify the file. There is a if file exists. So there is a exist function is there. So I will check if the file exists, then I will call the rename one. If file doesn't exist, I will not do rename. Okay, so I can merge it, these two code. So file exists, I will check first file exists. And if file exists, here I can call the rename function. So what I'm doing here, renaming a file. So this part, this renaming things, right? HDFS rename original path and updated file path. So I can call in code here, file exists. So here, when the file is present, now I can call here. Okay. So now I have to give two paths, original path and the exist file path. This is exist file path. So I will give the exist file path or new file path. I have to change the new file path. So I can use it here. So when the file is present, then I can check accordingly. So rename file will be renaming a file on a particular file we can rename. Okay, so now I'm renaming to the hello. Okay, so actually it's a folder name I have to change. It will not give error because that folder is there, right? So that's the reason it is copying renaming file in the different location. So workshop one. So rename is like a MB command, right? We use copy and MB. Okay. So now the file is with this name. 1.3, if I check it, there's no file hello.txt. So this way you can run program and you can see, I think workshop one I given. Yeah. So this way I can do the rename. Okay. Okay. So, 10-minute break and I will show the Mapreduce code. Okay. So Mapreduce program. Okay.
Can we get
10
this?
minutes.
Can we get this simple codes?
Simple.
No, these codes that you have, this copy, create, and all these ones.
Yeah, I'll give the code. This complete zip I will give directly.
Okay,
So you
okay.
can just import and then you can run.
So
Yeah.
we can learn from there. Because, yeah.
See, when you run it and then you will clear more like on more changes you can try, right? More
Exactly. Yeah.
like get list, right? I want to see the listing of all the files listing I want to see. So get list, right? You can do this one, get status list directory. So a specific path you can see your file listing. Okay, so 9,000 and you say here it is just showing the listing of the files. Okay, so this is showing the. So you can check in the Java is directory or is a file, right? That also you can check. So there is a method, right? Okay.
Sure.
Okay. Yeah. Okay.
One quick question though. On the is that EC2 you are using before to demonstrate how Ubuntu is installed? This Ubuntu installation that you were.
It's a simple light EC2 instance, and I just.
Okay. I was wondering what you are using here to do this. Okay.
So just launch instance, and then you select you just give a name of the instance.
But you can't run Ubuntu on that though. It's not a virtual machine.
So this is Ubuntu, right? Which version of Ubuntu, and then you select.
No. Just this interface, the EC2 interface. I said, can you launch all these launch Ubuntu here as you installed it here? I saw you did installation here.
Which installation? Okay, already this one, which I am running.
The demos, the installation demo, that you went through.
Oh, this one, this one.
No. This is idea, isn't it? Yeah. Before we got here, you did the Ubuntu installation.
The commands, right? Ubuntu installation command.
No. What I'm saying on the he did it on EC2 because he said it because you already have Ubuntu installed, so you couldn't do it.
Yeah, this Ubuntu, right? These are.
So what I'm saying, what is the EC2 used for?
EC2, like EC2 is Elastic Compute Cloud. You can create any type of EC2 machine you can create. Like suppose you need Windows, you can create Windows. If you want Mac you can create. Even Mac machine you can, Red Hat Linux, right? So there are the SUSE Linux is there. So they have given the different flavors you can choose, or Amazon Linux is there. One image is there. So it is a Amazon machine interface image.
I see. So we can install Ubuntu and all the accessories and run it there instead of
VirtualBox instead of the VirtualBox, right?
Yes.
Yeah, we can do that. That is, once your Hadoop is installed, then you can practice the same command you can do.
Oh, okay, but because
okay.
it looks fast.
Yeah, actually, it gave some problem on the Hadoop installation. Otherwise, once Hadoop is installed, you can run here all the command you can run, right? But you don't have any UI interface is not there, right? Because this is a virtual machine, right? Without interface, machine without interface, right? You don't have the interface like this. You can go inside that and you can create. So if you want to use you can't use the IntelliJ there. Right.
Oh, okay.
So IntelliJ you can't use it, but you can create a program and then you can create a jar and then you can run using Java minus jar command. Okay, there is a Java minus jar command like this. You can use Java minus jar and your main class. Suppose I want to run this list directory. So if I run on the command line this command, so my this class will be. So this ID is used for the development, right? Initially you are like testing plus development. But finally, when you want to deploy something on the server, so server you will not get like this UI, right? You will not get. In that case, you have to create a jar of this project and Java minus jar main class you can run. Then same result you will get whatever is coming. Okay. So here I'm showing it very fast, right? Because I'm just in the IntelliJ IDE itself, I'm running my program. But if you want to run on the server, so same thing I can do on the where Hadoop is installed, right? I can run my application, right? The same thing we will do for Hadoop Mapreduce and as well as we run for the Spark, right? We do on the cluster. Okay. Okay. This is for testing, like we are doing in IntelliJ.
Yeah.
Okay. Okay, 10 minutes I connect. Okay. Yeah. Are you getting my voice? Hello?
Yes.
Okay. Okay. So for Mapreduce concept, I've created document. You can follow this document. So it is starting from the Mapreduce fundamentals. Okay. So what is a mapper? What is a reducer, partitioner, combiner? So these are the some sort of concepts are there. So how we can learn all these concepts. Okay. But practically coding purpose is not required Mapreduce because it's not needed because nobody's asking to write code, but at least theoretical and fundamental concepts, right? We should be aware. Okay, so how to use the Mapreduce basically, and what are the fundamental concepts are there in the map and reduce. Okay. So I will take one example of the word count program, and then you will understand like where how the mapper works and how reducer works. Okay. So Mapreduce is used for processing the data, right? Mapreduce is for the processing the data. Okay. So I can take some input file and that file I want to process and I want to generate a one output file. So my input is one text file, and this input text file has some text of lines are there. So some words are repeated. Okay, so what I want to do, I want to just write a Mapreduce code for this. So for Mapreduce code, we need to write a three files. One is a driver class. So driver class is your starting point. Execution point will be starting from the driver class. And this driver class will have a main function. And this main function, you will start the some job object. So job class object you will create, and new equal to new job, you will create a job object, and then you will be setting your different classes like job dot set mapper. So you will set the mapper class. Okay, so three classes you should have. One is a driver, one is a class mapper class. Okay, so you will be creating a one mapper class, and one class will be reducer class. Okay, so mapper is implementing map function. It will be having a map function. So map function will be overridden and we will be writing the body of map. Okay. If what I want to split the data. So suppose I'm saying I want to get this input file and I want to separate the data into different mappers, right? So that logic will be written in the mapper. And the second phase is the shuffle and sort, but there is no class is required because it's internally done by the Mapreduce shuffle and sort. Okay. And after that, so driver is calling mapper, then mapper is calling shuffle and shuffle and sort will be giving output to the as a input to the reducer, and reducer has the reduce function. So reduce function is basically have the code of aggregation of the keys. So you have a different mappers have the different keys are there, and you will aggregate the same keys together. So then you will combine the result. So that part will be done by the reducer. So when you say the map reduce means it's divided into the two part, one is map and second one is reduce. So map is basically splitting the data into the number of mappers machine, and then the map in output is given to the shuffle and sort. Shuffle and sort is basically shuffling will done, right? If the same key is on the three different machines, so it will come together by shuffling, and the sorting it will do also. So suppose your key is hello, one key is word, so H will come first, word will come second. So that sorting will be done. And finally, the output data will be written into the output file after your aggregation. Okay, so shuffle and sort is just bringing the data together. Okay, but final aggregation things like word is coming how many times? 2 times. Hello is coming 4 times. So hello comma 4, word comma 2, that will be the final result. So shuffle and sort will be returning result like this: hello comma 1 comma 1 comma 1, and word will be 1, 1. So this will be written by the shuffle and sort. What map will be giving input? Map will be giving output. Map will be giving output like this: hello, 1, hello, 1, and hello, 1, and hello, 1. So how many times hello is there? So hello will be written. How many times word is there? So each word is giving 1, 1 count. Okay. But when it is coming to the shuffle and sort, so it will aggregate this hello from the different mappers and bring it together to the reducer. And reducer is finally returning output like this: hello, 4, and word, 2. That is a reducer output. So this way Mapreduce works. So Mapreduce is basically taking an input and it is basically dividing the data on the block size, okay, in the input split. So input split, the input file is divided into input split based on the block size. Based on the block size. Suppose I'm using a 64 block size or 128 block size, it will be distributing the data into the block size, and then it will be called input split. And this input split is further divided into the record reader, record by record reader. Okay, and then map function will apply. So the map function will split the data into the number of mappers machine, and next phase is a shuffle and sort. So map will be emitting the data. Map will be emitting data word, 1. So every key, 1. So word, 1. So how many words are there in each mapper machine? The same thing will be. So this will be happening on the different machines. Okay, this is a one machine. This is a second machine. So this is on one machine happening. One machine. And this is the second machine, right? So all they are running parallelly. Okay. And once this is written, then shuffle and sort will be combining the result together in a one single place. So it will be returning the output like this one. So shuffle and sort will be giving output similar to this. Okay. And once this output is given shuffle and sort to the reducer, the reducer is doing final aggregation. So after that, reducer is called, and reducer is basically giving final output file. And that final output file has your word count like hello, 4 and word, 2. So this output file you will get as a like your result. Okay, so this is the way like it's doing. So if practically if we see that how the code is there, okay, so we can run the code in IntelliJ or we can run the code in the, so first we have to create we can run the code in the cluster also by hadoop jar command. So first we are creating a like a project, like I created a Mapreduce WordCount project. So similar thing like I created here like one project. Okay, so I created a new project, and this project I will create a 3 classes. So I will create a one class, I say word driver. Okay, so this is the one Java class I created. Second Java class, word mapper. Okay, and the third one is a word reducer. 3 Java classes I have to create. And once I create these 3 classes, so I have like word mapper, okay, driver. This is my driver. So driver code, if you see the driver code, the driver code is creating a first, like in the main function, we are creating a job object. So some job object I'm creating and I'm setting the mapper class. So I'm telling here, what is my mapper class? What is my combiner class? If I'm using combiner, I will tell what is a combiner. What is my reducer class? So I'm telling about the all those classes here. So my code will jump from here to mapper, and then mapper will call the reducer, and reducer shuffle and sort will automatically call, and reducer will call. And finally, when the reducer is done, my control will come back here. Suppose I have a partitioner class also. So everything can be configurable. you can configure from your driver class, everything you can call it from here, because it is a starting point and it is ending point. Okay. So when everything, like all executions are done, then you will come back here. And finally, you will be completing your job. Okay. And you are adding the input format and output format. So I'm providing as an input command line parameter args0. I'm providing, this is my input file and this is my input directory path, output directory path. So output directory path is nothing but your file will be generated in some output directory. So that directory path I have to give. And I'm setting also output key class and output value class. So output key class means, so whatever my output is there, that should be a text type key class. So everything in the Mapreduce is key value pair. So when you are giving input to your mapper, this is key value pair. So when input file is given and when the map, so map is taking your input, map function is taking input as a key value pair. So what is key here and what is the value here? So key, I will say every line is having some certain positions is there. How can I say this line is coming first and this line is coming second? Because there is some offset position is there. Offset means this line is starting at the 0th position, and this line I will say is starting how many length of this characters are there in this line, that will become the offset for the next line. So I'm just assuming it is a 20. But in practically this number is not the same. There is some reference number is there as an offset. So offset is just telling about when you are reading the file, what is the position of the first line or second line. So this is maintained by the reference, like using the offset. So when you are giving input, this input file, so every line has some position. So this is called key and this is called value. Text of line is a value. So this key is a type of long. Okay. So one more thing is in Hadoop, everything is serializable, because data is transferring over the network. So when we are doing some manipulation on the data, so primitive data I can work, right? I can integer, numbers, sort, double, right? I can work. But when the data is transferred, then it's a serializable data. So there is a writable class is there, long writable. So long writable is a type of the class which is used for the long, double writable, long writable, or for string type, there is a text type. So when you see the code here, when you see in the Java code, right, in the mapper class code, so you will see we are passing as an input as a text type. Text is an input. Okay, this input is a long writable and this input is a text type. So our mapper class has the long writable and the text type. So long writable, here I'm using object, but it is a long writable, right? Okay, because my reference key is offset can be a long. And int writable is, and these two are the input type and these two are the output type. So input type is for reading the data, and output type when you are writing the data on the context. So context is one common variable. If you see here context, so this context is nothing but, suppose you are reading the data from one machine and writing the data in the same machine, and that will be available to the another machine. How the data can be shared? So there is a one common variable is there, context, that is shared across the machine. So whatever you are writing in one machine in context, that will be available in the another machine from the context. So in the mapper machine and reducer machine, how they are communicating to each other by using this context object. So this context type object, you are writing your data, you are saying context.write and you are saying word comma int writable 1. So suppose I got the line of text and I'm iterating that line of text. I say first word, second word, third word. I'm just writing as a int writable 1, right? I'm just giving a value 1. So once my data is written in the mapper, for all word, I'm giving 1 count. Then I will call my reducer code, and reducer code, what it will do, it has a reduce function. So initially my total is a 0. And I'm just trying to get the value of each key. So here is I'm getting the again two input type and two output type. So two input type is key comma value, that is input type. Like my input is coming key comma int writable is a 1. But my output type will be final output type. Like, okay, I'm saying key and value, the total sum. Okay, so what I'm doing here, once I'm taking the data as a key comma value, so first I'm just doing the manipulation here because my key has multiple values. This int writable is a value type, list type values. Okay, so I have to iterate all the values, but all the values are 1 1 1 1 1. So how many ones are there? I have to add those ones. I have to add those ones, and finally my result, right, I have to set in the context. And once after I set in the context, right, in my reducer class, so it will be available like as a output file. Okay, so when you want to run any program, right, you are writing a 3 classes. Okay, so mapper. Okay, so I just copy these 3 classes, simple word count program. So I'm copying these 3 classes here. So I'm pasting the classes. Okay, so so initially error it will show, but I have to do, because this partitioner I'm not using, I will remove it here. Okay, so I'm not using partitioner. So now this is my driver, mapper and reducer. So how to run my driver class? So I will do edit configuration, plus icon. I will create an application type. So I say here, so locally I'm running. Okay, this is my Mapreduce app. And here I have to tell my driver class name because my program will start from the driver. So word count job, this is my driver class. Okay, and pass the parameter. So I have to tell my program, right, what is my input file, which file I want to process. So I just take it the location, right, any file I take it. Okay, this hello.txt. I take it this location, giving as an input file. So I'm giving in my here and giving the file name is hello.txt. And next I have to create an output file path. So output directory should be new. So this Mapreduce underscore WC, I'm giving a WC output, some new directory I'm creating. So once I set it this parameters, now I can run my application. So I just created a project. I added a 3 files here, driver, mapper, reducers. And then I just created an application runtime here. I created an application and that application I'm running. So here it is running without cluster. It is not using any cluster. This is just running a program by using the jars. Okay. But the same program, I can create a jar and then I can run on the cluster, the actual cluster. Okay. So for testing purpose, we run in the IntelliJ. But when I want to test in the cluster, then I have to create a jar of this project. And then I have to run my driver class. So my code is completed. So this exit code is 0. If you see in the driver class, so there is a condition is there. If this wait for completion is true, it means it will return 0, is successfully returned. If it is fail, if some error comes, so it will return the 1 code. Okay. Second time I can run this program and it will delete my output directory and automatically create a same directory. But generally, if I'm not using this code, so every time you have to give a new directory. So that is basically a condition. Whenever you are running a program, every time you should give output directory should be new directory. So now I have to verify the output result. So I have created my output here, WC output. What is the directory name I given here? Mapreduce underscore WC and WC output. Here it is creating the 3 files. One is empty, but partitioner I have not used. Okay. Okay, so my output is coming here, this file, and what is the input file I'm giving here? So input file I'm giving in the same location. The same location I give in the input file is hello.txt. So this hello.txt words, I'm just getting the output. Okay, but why it is creating a 3, I'll tell you the reason. Actually, I disable this combiner partitioner, but still I giving the num reduce task 3. Even your output will come in the one file only. No need of 2, 3 files. 3 files, this configuration, these 2 lines of configuration like set partitioner class and set num reduce task is for partitioner. So when you are not using the partitioner class, so then you should not use the reduce task also. So it will not create a multiple output file. It will not create a multiple output file. It will create only one single file. That is a default. Okay. But when you want your output into multiple output file, then you will go for partitioner class with set num reduce task. So that is the reason your one file is getting output and other 2 files are empty, because the code is creating the files, even the data is not written. Okay, but files are creating. Okay, now I'm running again. Okay, so now only one file came, part R000. So I reload data. So same output will not change. Output will come same. And one success file is created. So this success file indicate this is an empty file. Nothing is there. It's just an indication, right? Your job is completed successfully. And output directory, it will create the file naming convention is part R0000050. Suppose your 2 files are there. So R00001 file will be created. So actually this file naming convention will be coming automatically, right, by giving the Mapreduce. So how many output file it will create it's a reducer output file. Suppose your output is not coming reducer, your output is coming from the mapper. So this file naming convention will change. It will become part M0000. So that will change accordingly, whether your job is reducer output job or your job is only mapper. So when you remove this reducer, when you say, okay, I don't want to use reducer, my output will come directly from the mapper. Okay, so I will not use this reducer class. So that job is called map only job. So map site join is there. I will tell about that, how we can do. Okay, so this is the simple word count program where I have a driver class and I have a mapper class. So mapper class logic is I'm just writing each word as a 1 count. Okay, so here I'm iterating the data. I'm tokenizer, I'm iterating the data. Another simple way you can do it, like you can split this text line, right? This string. So you convert into the string and then you can do string array. You can say like this string, and then you say array, and then you say input dot to string. Okay, and after that you can iterate the for string s and this array. You have to do split function after this split, and then you say I want to split with the space. So either you can write like this. So now it is an array, because suppose there are the 100 values are there in the same row. So you will get the 100 value array and you will iterate each value. And now you can write very simple code, this line here. So tokenizer is the one way. Who knows Java, they know like this tokenizer. Okay, so you can write this as every word you will write as a 1 count and the context. So this all code is not needed. This is the alternate option, right? See, as much line code you can reduce it. This code you don't need it. Okay, because same thing, whatever you can do there, you can do it here. Okay, so this context, whenever you are writing in the context, you cannot write the string data because this is a primitive data. So you have to make it serializable, like you make it serializable here, int writable, because this one value is a primitive data. So you have to use new text type, new text. And then you will write the data into the serializable type. Okay, it is asking for the unhandled exception. So actually this for loop is not, this one is, we have to comment. Okay, now it will work. So this code I change it, like same thing, whatever I was doing tokenizer, I just change it to this. Okay, counter is a different concept. Counter is a different purpose. Like when I want to debugging, I want to find some wrong input word, right? Or some null data, missing data, I can use counter. Okay, so that's a different concept, but I can use it the same thing when I run it. So mapper logic is there. This is the one simple logic, right? Like context, just you are splitting the word and giving each word one count. See, now it's running the same program. Okay, so output will be coming same. Okay, so this is just a simple word count program. Now further one more step, you want to say, okay, I have repeated data more. So how can I improve my performance of the Mapreduce word count program? So there is a combiner concept is there. Okay, so if you see here, I have already one. If you see in my driver class, so here I am using the combiner. So combiner is this one. So combiner, I am giving a same reducer class. So suppose if I say this mapper, how many times one mapper has this hello? 3 times. So rather than giving hello comma 1, hello comma 1, hello comma 1 3 times, what I can do, I can aggregate the result in the mapper side, and I can return to the shuffle and sort hello comma 3. So what hello comma 1 I'm doing 3 times on this particular mapper. So I can do using the combiner, it will make it hello comma 3. So whatever the reducer is doing from the different mappers to combine the result, so same job will be done in the same mapper. So same mapper is the key is repeated more number of times, so it will make it one aggregate value. Okay, so it will become more faster, right? Suppose this hello is, I'm giving a one simple example, but suppose hello is a million times is there. So rather than going hello comma 1 million times or 1,000 times, 10,000 times, you will make it hello comma 10,000. So like that, you can improve the performance. So where you will see the difference of this combiner when your data is more repeated time in your code. Okay, so when your data is more repeated time is there in the data, right? So you can find the difference with the combiner. So just you don't need to write any class for that. Whatever your reducer class is there, just add as a combiner class. If you comment this, your combiner will not apply. But when you want to apply combiner, so you have to say this. If your data is not repeated, so combiner will not be any use. Combiner is used when you want to improve the performance at mapper side. Okay. And what is a partitioner? So partitioner, you are creating a one separate custom partitioner class, and you say you want to distribute your output into number of output file. Okay. So suppose I say I want to create a 3 partitioner, right? I want to create a 3 output file. So I'm checking the key. If my key is starting with F letter, I'm writing in a one single file. If my key is starting with the N letter, so I'm saying it should go to the second file, or rest of the word, which is not the F or not the N, it will go to the third output file. So partitioner is also mapper side, like it is applying once you are returning the data to the shuffle and sort from the mapper, the partitioner will distribute the output as per the key, right? What is the key is there, based on the key, it will be what is the logic you written for the partitioner class, it will be applied, and your output result will be distributed into the different reducer. So here you are saying reducer 1, reducer 2, so you can bring multiple reducer. So when you are using partitioner, we can. So if you are not using you are not using a partitioner class, If you're not using partitioner class, so that is the default is hash partitioning. Hash partitioning when you are not using custom partitioner class. So then default partitioning is a hash partitioning that is creating single output file. Okay. But when you want to use custom partitioner, so you have to write a custom partitioner class, which is extends partitioner class, and then you override the get partition function. So you override get partition function. There you write a logic. So it is taking two things, key comma num reduce task. So if you see here in the code, we are taking a key and we are taking a num reduce task or value. So key and value is everywhere we are passing as a key value pair, because everything like even the mapper, reducer, combiner, everything is taken by the key value pair. But here is a one more extra parameter is num reduce task. So this num reduce task will be basically, the purpose is how many output files you want, and as per this num reduce task you will write your logic. You will distribute your output into those number of output files. So this partitioner, so basically here I just mentioned it like my key is starting with F or my key is starting with N. I want to distribute my output file. So okay, so what the input I'm using for my this partitioner? Okay, I show you. I have a two files. One is a score.txt and one is my output directory. So score.txt file, okay, this is my input file and this file is present in this location. Okay. So one word count directory is there. Word count, this directory. So this word directory, I have a score.txt. So this is my score.txt. Here is I have a person A, person B, different person and country, and then I have a like sport. Okay, country and sport. Okay, so first I'm splitting this all data, right? It's a comma separated data. Okay, so once I just separated out data, so I will see here key. Now which key is there? So I'm using which key is there. So how I'm just writing in the Mapreduce program, if I go to the mapper. So this is a partitioner map. For partitioner class, what I'm doing, I'm just separating out the first comma and I'm saying it will be in the array, right? Every line will have 3 words, right? So one is a name, then is a country, and then a sport. So I'm saying text word 2 is my key and text word 1 is my value. So text word 2 means like sport. Sport will be going as a key. Okay. And the word 1 will be going the value as a key or value, right? The country. Okay. So like this, I'm writing in the context. And in the reducer, I'm doing the count of the game count, right? Like, okay, I want to check for particular country how many games are there. Okay, so that count I am doing here, the game count. Okay, so here I'm getting the list of values, right? As a list of values, and key I'm getting as a, which is I'm getting here key. The final output I'm giving key and game count. That is my key is my country, and game count I'm giving total number of count. Okay, of those games, sports. Okay, so custom partitioner logic I written here. I'm checking here. Okay, if the number of reduced task is 0, right? So if nothing coming, like, so no output file. Okay, only one will be there. Return 0 means only one. But if I'm checking the key is, if key is cricket, right? This, okay. So and value is not India, so I will create a one file. And if the key is this and value is this is an AND operator. Or rest of the other countries and the sports, I'm creating a file 2. Okay, so file 3. So 0, 1, and 2. So 3 files I'm creating based on my key logic, right? Okay, key and value. Okay, or you can only key you can use, like you can say, okay, I want all the data for one country in one file, rest of the one in the one other file. So you can write a logic on the key basis also. Okay, only key. But here I am using key and value basis. Okay, so when I want to run this example, so I have to check the driver class in this. So the driver class is partitioner demo class is the driver class. Okay, this is a driver class, and score.txt I'm giving an output input file, and output directory is output 6. Okay, I change it to 7. Okay, and now apply and okay. Okay, now I'm running it, my partitioner demo class. Okay, initially it could look tough, right, in the beginning, right, because these are the all theory plus practical concept. But if you understand as a theory also, that is also fine. Like what is the role of partitioner, what is the role of combiner, what is map side join, reduce side join, driver class. Okay, so now this job is done successfully. So now I check my output in output 7. So I get 3 files, part R000, part R001, and part R002. So when I open the part R0, so I'm getting this cricket, and this is a country name I'm concatenating. So if you've seen in my logic, I'm just doing the concatenation here here. So I'm just string dot val dot to string. So whatever is value is coming, right, list of countries. So I'm just concatenating for the same game. Okay, so here in the output, so I'm getting the England, Australia, England 3. Okay, so that is for non-India, right? Okay, 1 is India, so India is 6 times is there, so 6 is the total count, and 6 times India is there. So that is the one other condition. And third one is a rest of the other one. So they are the 2 countries. Okay, so I will be using this one. So that way I'm just giving my output. So same thing you can do for the simple word count program. I say I want to create for every I want to create the separate file for each word is starting with A letter, B is starting with the B letter. So like you can write 26 time conditions, right? So you have to just write a logic in the partitioner class where you can mention what the key, like if you say key start with A letter, so you will create return 0. Key dot start with B letter, so all word will go to the B letter file. Okay, is it clear? This one is like a partitioner. Okay, so one concept is there in the 2 types of joins are there in the Mapreduce, because we know the simple we have join.
Yeah, so here you see the number 1 and 2. So once we insert this partition, whether the first column will not come, should we remove them?
Which column?
I mean, if you open the CSV file.
Okay. This file.
Yeah, here if you see, there is a number 1 and 2, like serial number 1 and 2 is coming.
Okay.
So this will, should we remove them or leave it?
Oh, this name you are saying, file name?
No, not in file name. The column, if you open the 002.
Yeah.
First is one number base call Australia 1, 2. So the first line 1 and 2, where numeric is there, should we remove them?
But that removal things you can do again, read these files and then do further processing. See, this is the output of the Mapreduce. Okay. Now what you want to do further, right? You have to read these files and then you can do further processing. Okay. So here the output is expected based on the partitioner. If I don't use the partitioner, if I just comment the partitioner here, so you will see everything will come in the single file. Okay. So the partitioner will make it your all things in the different file. Okay, so where is my driver in the driver class? Okay, here. Okay, if I don't use this num reduce class, and I will say partitioner class also I commented. Okay, now you see the difference. Okay, now I've just I'm running the program again. And I will be giving a new directory because I'm not deleting manually. Okay. So I'm just running again. So output will come same, but now it will come into the only one single file. That's the only difference is the partitioner. Partitioner is making your output readable, human, more like easy way, right? This output is very small, okay, you can read it. But I'm saying if the situation comes like you have millions of words and you have in a one single file and you have a word frequency, and I want to say, okay, find the T letter word. So you will, all word will be mixed up, right? But if you are having partitioner, so T letter folder, like you will get all the one, right? You will get all the word in the one single file, right? See, only one file came because I removed the partitioner. Can you see that this is the similar way, like output, right? So it is just writing the same output, like same output. If you are not using the partitioner, it will be combined output, right? In a one single file, okay? So partitioner is making your file output in a more readable, right? Or more structured way, right? Like you can create a different output file, okay?
Okay, sure. Thank you.
Okay, so when next we go to the, like, so far we are working for the single file, right? So far we work for the single file, right? Okay, suppose I have two files. I say one is an employee and one is a department. These are the two text files. One employee has, okay, I say employee ID, employee name, and employee department ID. Okay, so suppose I have this data, department ID, okay, and I have a department having department ID and department name. Okay, so if I say I want to combine this data and I want to say employee detail, employee department detail data. Okay, so this file I want to create. So I want to say EMP ID, EMP name, and EMP department ID and department name also. Okay, so this kind of join, right? This is an inner join, right? I'm just simply combining the data, right, from the two data sets, right? So this kind.
I said you're merging the file, inner join. Yes.
Yeah, but inner join, we it's not a SQL query. We cannot write a SQL query like
I
join.
understand.
There,
I understand. I know where you're going. Yes.
So thing is here, we are doing this join through the Mapreduce. So Mapreduce says like when you are reading the join, so this is a department is a small data, and you can like fit into the memory because this department data will not change because your employee data can keep changing, right? Because number of employees will be joining and then your data will be growing, right? But department will be fixed, right? Very, very rare, like you are changing the department. So can we use this department as a distributed cache, like in the memory we can fit and then we can use it anywhere in any machine. Okay, so all the mapper can use the same data.
If the department the key.
Yeah, so department ID. So basically this column should be same column here, right? Department ID, and this department ID, I will create a hash map for this. And I will pass the key here and I will get the value of this and then I will append in my row. This is same like SQL query does, right? But how it will be done in the Mapreduce? Okay, so Mapreduce is basically there is a distributed cache concept, like how to store in the memory. So first thing is like I'm just having, this is my distributed cache, some API class is there. So whatever your department file is there, you will put in the your department cache file, you will keep it in the distributed cache, some directory. And this file, you will create some load department hash map, right? So you are writing a logic here, how to read a Java API to read this file. Okay, comma separated, you have the department ID and department name. So you are getting the two columns. One column is a ID and one is a name. And you are creating a hash map. You are putting the hash map with key and value. And when you are mapper, in the map function, when you are getting your employee data, this is employee data, right? Value.toString. This is employee data, all employee attribute. So your sixth attribute is suppose I'm saying my data is like the sixth column is my ID column, department ID column. So I'm passing the department ID and getting the department name. And then finally, I'm just formatting my text like this. I'm saying first is a ID, second is a name, then age, a lot of columns are there, and finally department name. So my output should be coming from the mapper only. Do you think here any processing is required? Any reducer is required? No. It is just simple type of processing, just simple. I'm just combining the data in the mapper itself, right? But suppose if I give an example, this is a map side join. Map side join is when your join is happening in the mapper side itself. That is the reason this join is called map side join. So map side join, very common join. It is there in the Mapreduce, Hive, you will get in Spark also map side join. So the concept is same everywhere. The concept is like when the small data which can fit into memory and you will add in the distributed cache and you will get it any node, you can get the data. Okay, so map side join is when the output is coming, when output is coming from the mapper directly, coming from mapper. Okay, coming from mapper. So here no need of reducer, no need of reducer. So if you see the output file will be generated, that will be part -m-000 of this one. Okay. So what is the need of reduce side join? Okay, reduce side join is when the join is happening at the reducer side. Suppose I say I have a two mappers, I have two mapper classes are there, mapper 1 and mapper 2. Mapper 1, I'm saying like I have a customer data is there. Okay, so customer ID, customer name. Okay, this is another example, and order ID. Okay, and I say here in mapper 2 that is reading the order data, order ID, order description, and order cost. Order ID, order description, and order cost. Okay, suppose I say the scenario, if for the one customer who has purchased, one customer 1 has purchased 4 times. Okay, so how many order record will be there for this guy? 4 times. So 4 order record will be there. Okay, for the same customer ID, forward order records, right? For the same customer ID, same customer ID. So here I want to do inner join. Okay, here also inner join, but here is I want to aggregate the all the orders of the customer and I want to get the total cost. So suppose I say the total cost is like one time he purchased $200, sometime he purchased $300, $100 or $100. So I should get it the final output result 700. So 700 I should get the total 4 times he purchased. So this join is a reduce side join. So in this join, I have a 2 mapper and 1 reducer. Okay. So how can I identify, because reducer doesn't know which mapper is coming, because reducer is getting this is the customer mapper or this is the order mapper. So what we will do when we are sending the data in the context, right? When I write in the context, so when I'm writing in the this order customer mapper, I will write in the like this context dot write and key. Suppose my customer ID is a key. So customer, some prefix I will add it or suffix I will add customer like this. And then I will add my customer name, because for customer I need a customer name. Okay. And if I say for order 1, I will write here in the context, I will say, because customer ID is a common here, right? Because customer ID here also I need it, but I will say this is the order. For I don't want to do be any confusion, right? If this is a order or customer. So this customer ID I'm giving a customer and this customer ID I'm giving order. So customer ID is same here. So when I'm just getting both the record in the reducer, I will identify for the same customer how many orders are there. And here I'm getting the amount, order cost, individual order cost. Okay. So in the reducer, when I am writing a reducer code, I will iterate it all the order of same customer, all order of same customer. Okay. And then do the sum of total cost, like sum plus order cost. So final sum is my total cost. This sum will be total cost. Okay. So this logic I will be writing like this. I just give an example. So reducer side join, the simple, I'm just giving example here. So customer mapper is there, right? Customer mapper is what is writing part 0, like it's a customer, like it's a like customer ID I'm saving, but I'm I'm saving every record with the customer
First.
prefix. Okay. So that I will identify in the reducer. Transaction mapper is transaction data, like order data. So here I'm just adding the transaction, right? And this is the amount. This is the amount because amount field is needed. Okay. And when I'm getting in the reducer, so you see here, first I'm just making a double total, my total 000, and total number of transactions also I want to calculate. I want to get the result like total number of transactions and total number of total amount. Okay. So what I'm doing here, I'm checking this, whatever T is coming, this value is coming. Okay. But this value we don't know, this is a customer or transaction. So I'm checking here the part of 0, either it's a transaction type or it's a customer type. If it's a transaction type, I'm doing the count first, how many transactions, and total count, total I'm just doing plus. Okay. And if it is a customer, suppose if it is a customer, right? So I will take his name. Okay, because I'm saving with the, I'm passing here customer hyphen part 1. This is a name. I will show you the data, what is data look like. Okay. And finally, reducer is doing context.write. I'm writing as a text name, the customer name, and what is the format of count plus total cost. Okay. So when I go to reduce side join, what is my input file? My input files are, one is a transaction detail file. Okay. So this is my one input file, and one file is a customer detail. So one file for the mapper, customer mapper, and one file for the transaction detail mapper, right? And this is the third one is my output file location, right? So this is my output file location. Okay, so I give some different for the different one. So I show you the data first. Okay, so here okay, so this is done. I check it. Where is my input and where is my output? Okay, my input is in the WC. Okay, Mapreduce WC. Okay, so this folder, this one. So here is
2345. Yes, that.
so you can see here the test is a 1. He is having 2 transactions, and this is a total amount. This person has 1 transaction, so total 1 is 89. 1 is this, so this is the total, and this guy has no transaction, so 0 transaction and 0 amount, right? So how the input data, right? Okay, I want to see the input data, the transaction, and this is the transaction detail, this is the customer detail. If you see the customer detail, so customer ID, customer first name, last name, age, or some fields are there, and transaction detail has the transaction ID, transaction date, and this is a customer ID. So this is here common, right? 4001. So 4001 is here only 2 times. 4002 is 1 time, and 4003 is 1 time. But 4004, there is no transaction for this test 6. So there is 0 amount is coming. So I'm having all the data, but I'm using this amount data and this customer ID data. Okay, so this is reduced side join, and the distributed cache, like the map side join. So where is my employee file is there? Okay, if I want to see my map side join, so this is my map side class, because there is no reduced side class is needed. Okay, so one is a driver class and one is a map side class, right? Like a mapper class. So for this one, map side join distributed class. So this class, so here I'm just saving in my distributed cache directory on the Hadoop file system. So I have to run this program on the Hadoop file system. So this distributed cache directory I will be creating in the Hadoop file system. So I'm just, when I'm running a job, right? So this one, So here I'm giving, this is my employee.tsv, employee TSV file. This is my input file, and this is my output folder. So same thing I'm doing on the Hadoop file system. So first of all, okay, so I'm here in this directory, open in terminal. So here, so I have to create a jar, like how to submit on the clusters. Okay, I'm showing this thing also through the jar. Okay, so first I created a jar. So I have created a Maven dependency, Maven repo. So this is my clean package I'm doing. So I'm doing creating a jar. So if you see edit configuration, so here clean package I'm doing. So it will create a jar of my code. Okay, so same thing like when we are doing the Spark code, right? Spark with Scala. So Spark with Scala is running with the Maven, right? So similar way we have to create a jar. So I will be creating a jar. I will run the application. Okay, the Maven application I run. So it will create a jar. All the classes, even the hdfs API code will be going also, because that is in the same project. But the package is different. Here the package is this hdfs and this classes are in the different. So my jar is created. I copy this jar. I keep it here in my any folder. I copy it so that I will run it this jar. Okay. So when I want to, okay, I see hadoop fs minus ls slash. So there is a directory Mapreduce wc. So this Mapreduce wc is having my distributed cache directory. Okay, Mapreduce. See, because this path I have given in my code. So when I'm just building my code, before that in the driver class, which directory I'm setting as my distributed cache, where my, so this is my Hadoop directory. I'm saying Mapreduce wc department.txt. So this is the file in my Hadoop file system as a distributed cache. Okay, so I will use Hadoop fs minus cat. So I will see the content of my all the department IDs and department names. Okay, the comma separated. Okay, and other one, if I see Mapreduce also input file also, because when you are running on the cluster with the jar, you should have your input and output should be on the Hadoop file system. Okay, so here ls. So Mapreduce wc has employee underscore tsv file is there. This is my input file, right? Okay, so this file content I can see by using cat command. So I say here not dc, it is in the employee underscore tsv. So I will see my all employee data. So this is employee data you can see, and departments are here D005, D007, right? Now I want to generate my output file in some output directory. So first I will be doing Hadoop jar command when I'm running on the cluster, Hadoop jar, and my jar name is Mapreduce this jar, like whatever jar I created and copied here. So the jar is this Mapreduce wc. And then I have to provide my input file path. So my input file path is distributed cache path. I don't need to provide because that is already configured in the my driver, right? So I have to provide my input path. So Mapreduce underscore wc employee underscore tsv, and output path I'm giving Hadoop path. So Mapreduce underscore wc, and I say some output one, output some other folder which is not present. So output 5 I'm giving. Okay, so here my output will be employee Mapreduce wc employee tsp. Okay, one parameter I forgot. Actually, after the jar, you have to tell which driver class you have to run. Because whenever you want to run any Java class, you have to tell Hadoop jar name, and then you have to tell the driver with package. So my package is, in which package this class? org example. So org.example dot my driver class name. My driver class name is this. Because in this jar, so many classes are there. How can you say this particular class is your main class? So whenever you are running a class in your Java class you want to run, or any Scala class you want to run, okay, object you want to run, so you have to specify. Okay. Now your job will be started. So whatever you did manually, right? When you run here, right click and you run it directly. Okay. But distributed cache you are not able to use locally because you have created a cache in the Hadoop file system. Okay. So that's the reason we are doing testing of this one in the Hadoop file system. And it is creating, and it's done. Now I check my output file. So what is my output directory? Output 5, right? So I just, the file naming convention will be the same, the part M, because this is the mapper output data. Okay, so we do Hadoop fs minus cat. Okay, and then I say part hyphen M hyphen 5 zeros. It's a default. Can you see here the D005, the department ID and department names are coming. So this is the join. So this is called map side join when the output is coming from the mapper output. Okay. Okay, so this is all about this, right? Okay, so Mapreduce, so you can execute this code, programs, right? Everything you can execute, right? So you have to set up the IntelliJ in the Ubuntu, then you can set up and then run.
Are you going to are you going to send the files maybe? Are you going to send the files?
Yeah, I will share in the location, right, where I will share
Yeah,
the
so-
video
okay.
drive, and the same one I will share the recording as well as this source code.
This is
Okay,
really-
so that you can do.
this
And
is
one
really-
more thing is there, the
really
curl
deep.
command, actually one curl command is the pending. Okay, so that curl command also you can practice, like how to access your HDFS REST API. Suppose I want to create a directly by the command, so I can create by using just simple one single command, you can create a directory. Suppose you don't have the access locally, your Hadoop file system, but you want to create, so just you do this, and suppose I have already this here, this path is predefined, localhost 9870 wave SDFS v1. After that, I'm giving my directory folder where I want to create my like I want to read the file. Okay, open. So simply, okay, so I say here this one. So this is giving the content of the file. So you should get the status code, right? You should get the status code. So you are getting the status code OK 200, and you are getting the content of the file here. So you can create a directory also. So create a directory is a simple, like you have a create a directory, write a file, rename a file, and make a new directory. So I have already some directory. Okay, so I'm just changed to this directory I want to create. This folder I have, okay, this is my root directory, and I'm saying opmkdir. So just this command I will run. I should get the status code 200. So I'm getting a status code 200, and now I can verify Hadoop fs minus ls slash mapr. So mapr is a directory where I created. Okay, so I should get the who 4. So I'm getting this one, right? This one I'm getting. So this is the way, like a curl REST API command. Okay, so you can find more command on the curl, like REST wave HDFS REST API. So like this, you can.
A lot of commands to remember.
Yes. There are the 3 things only, right? Either you will be doing either using a local command, or you are using a programmatic way, or you will be doing REST curl. So this is the official documentation, right? Wave Azure. So these many all operations you can do. Rename a file, delete a directory. So all this call command syntax they given. So just you have to change your path, change your operation, and change your username like a permissions you have to change, so you can get it. Okay, so you can do these all things like, yeah.
Oh, that's
You can
nice.
set it. Okay, thanks everyone for attending session.
Thank
So
you.
tomorrow I
That was
will
big.
do high.
That was comprehensive. Thank you very much.
Thank you. Thank you.
Yeah, thank you.
Okay.
Really comprehensive.